Hello. So this is the sixth part of my math journey in Khan Academy. So I'm still in arithmetic, 43% in, and last thing I did in the part five was the negative numbers. So it was pretty quick, 1500 points, and now we're into fractions, which is pretty huge. That's exciting. So yeah, am I recording? Okay, I'm recording. Let's go. Is my voice heard? How about cans?
What we're going to talk about in this video is the
Yeah, okay.
idea of a fraction. And we'll see there's many ways to think about a fraction. But first we'll think about the most fundamental. So let's say that I have this square. And this is the whole, we can consider this a whole. So let me write that down. This is a whole. It is a complete square. Now what I'm going to do is divide this into 4 equal parts. So with one cut like that, I've divided it into 2 equal parts. And then with another cut like this, I could divide it into 4
equal parts.
4 equal parts. So there are 4 equal parts. And now what I'm going to do is I'm going to select one of those equal parts. So let's say this part right over here. I am going to select that. So the question is, what fraction of the whole is the part that I have shaded in red?
I guess.
Well, it is 1 out of the 4 equal parts, right? I've shaded in 1 out of 1, 2, 3, 4 equal parts. So we write this as this fraction, this piece represents 1/4 of the whole. And there's two ways that you can think about this. You could view this as one of the 4 equal parts, or you could view this as a whole divided by 4 would get you exactly this much. Now let's do another one. And this time, let's think about how we could represent 1 over 8.
Wow.
So 1 over 8.
Parts.
Well, we could divide this whole. In this case, the whole is this rectangle looking thing. We could divide the whole into 8 equal parts. So let's do that. So here I've divided into 2 equal parts. That looks pretty good. And now I can divide each of those into 2 equal parts to get me 4 equal parts. And then if I were to divide each of those into 2 equal parts, I will have 8 equal parts. And it's not exact. Obviously, I've drawn it by hand, but hopefully this gets you a sense. So now I have 8 equal parts. 8 equal parts. And now I'm going to select exactly one of them. And that'll represent 1/8. And I could select any one of these, but I'll just do this one to show you it does not have to be necessarily the first one. So once again, this square right over here that I'm shading in red represents 1/8 of the whole. Now let's look at a few more examples where I've shaded them in ahead of time.
Wow.
And what I want you to do right now is pause the video and either in your head or on a piece of paper, write down, if you consider this purple thing the whole, what fraction does this red part represent? If you consider this blue part the whole, what fraction does this red part represent? If you view this yellow triangle as a whole, what fraction does this red part represent? And so I encourage you to pause the video now. Well, let's look at each of these. So in this case, for this rectangle, we have 3 equal parts, and we've shaded in one of them. So this red rectangle right over here represents 1/3 of the whole. Now over here, in this kind of pie looking thing, this circle looking thing, we have 1, 2, 3, 4, 5 equal parts. 5 equal parts, and we have shaded in one of those 5 equal parts. So this little slice of the pie, this represents 1/5. This right over here is 1/5 of the entire fraction, or of the entire pie. Now this one's interesting. You might be tempted to say, well, I've got 4 parts and then I've shaded in 1. That must represent 1/4. But remember, it needs to be 4 equal parts. And it's pretty clear looking at this that this part right over here is not equal in size to this part right over here or this part right over here. These are not 4 equal parts. So we cannot say that this is 1/4 of the triangle. So you cannot say that.
Oh, that ended abruptly. But wow, it's a lot of videos.
Is each piece equal to 1/4 of the area of the pie?
No.
So we have a pie, and it has 1, 2, 3, 4 pieces.
Those 4 pieces,
So it does have
but
4
they're not
pieces. So is
equal
one of those
sizes
pieces
or
equal to
area.
1/4 of the pie? Well, let's talk about what we mean when we have a fraction like 1/4. The 1 in the fraction, the numerator, represents the number of pieces.
Oh,
so
it's
here, 1
Grill again.
piece, 1 piece of pie. And then the 4, when we're talking about fractions, is always talking about the number of equal size. Equal size pieces. So in this case, 4 equal size pieces. So the question is each piece one of 4 equal size pieces? Let's look at the pie. I think it's pretty clear that these pieces on the end are not equal. They are smaller than the 2 pieces in the middle. If you love cherry pie, you are not happy about getting this end piece because it is smaller. It is not an equal size piece. So yes, each piece is 1 out of 4 pieces, but it is not 1 of 4 equal size pieces. Therefore, it is not 1/4. So our answer is no, 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 no. Each piece is not 1/4 or an equal share of the pie. This question says, Vera's dinner plate is divided into 3 equal size sections. Vera puts all her broccoli in one section, and then we're asked what fraction of Vera's plate
1/3.
has broccoli.
Let's go.
Okay, so we have a plate with 3 equal size sections, and we know that Vera puts broccoli in one section, and we're asked to figure out what fraction of the plate that is. So we can draw Vera's plate, try to represent this with a picture. Maybe Vera's plate is a rectangle, we don't really know, but a rectangle will work as long as it has 3 equal size sections. So let's try to draw that. This may not be perfect. We could probably do that second one a little better. But this should represent 3 equal size sections on a plate. And then we know she puts broccoli in one of those sections. So let's use green, draw some broccoli. Broccoli.
Broccoli, broccoli.
And
I love broccoli.
then look at this picture and ask ourselves what
Broccoli.
fraction of Vera's plate has broccoli.
What fraction?
Well, our fraction is going to have a numerator. On top will be how many sections have broccoli, which is 1. And then our denominator will be out of the total number of equal sections.
Whoa, denominator.
And we know there are 3 equal size sections. So 1/3 or 1 of the 3 sections has broccoli.
That's true.
I have a square
1/3
here
of the
divided into
plate is
1, 2, 3,
That's
4, 5, 6, 7, 8, 9 equal sections. And we've already seen that if we were to shade in one of these sections, if we were to select one of these sections, let's say the middle one right over here, this is 1 out of the 9 equal sections. So if someone said, what fraction of the whole does this purple square represent? Well, you would say, well, that represents 1/9 of the whole. This thing right over here represents 1/9. Now, what would happen if we shaded in more than that? So let's say we shaded in this one and this one. So let me shade it in a little bit better. And this one and this one right over here. Now, what fraction of the whole have we shaded in? Well, each of these, we've already seen, each of these represent 1/9. So that's a 9th. That's a 9th. When I say 1/9, I could also say a 9th. So this is 1/9 or a 9th. So each of these represents a 9th. But how many of these ninths do we have shaded in? Well, we
4
have
ninths.
1, 2, 3, 4 shaded in. So now we have a total of 4 ninths shaded in. 4 of the 9 equal sections are shaded in. So 4 ninths of the whole is shaded in. Now let's make things a little bit more interesting. Let's shade in. So here I have 5 equal sections. Let me
What
write
if
this
shade
down.
everything?
I have 5 equal sections. And let me shade in 5 of them. So 1,
Oh, yeah.
2, 3, 4, 5. We already know that each of these sections, each of these shaded in sections represent a fifth. So 1/5, another way of saying that is a fifth, is 1/5. But now how much do I have shaded in? Well, I have 5 out of the 5 equal sections shaded
Still a
in, or
whole.
I have 5/5 shaded in. And you
Five
might be
times
saying, wait,
one.
if I have 5 out of the 5 equal sections shaded in, if I have 5/5 shaded in, I've got the whole thing shaded in. And you would be absolutely right. 5/5 is equal to the whole. Now what I want you to do is pause this video and write down on a piece
What's
of
the
paper, or at
fourth
least
one?
think in your head, what fraction of each of these holes is shaded in. So let's
Alright, that's 4, 6, 5, 4/5. That's 2, 2, and what the hell is this? It's so weird, man. But they're not equal
go to this
parts.
first one. We have 1, 2,
Really suck
3,
or
4,
something,
5, 6 equal sections.
Or a dick.
6 equal sections. And we see that 1, 2, 3, 4 are shaded in. So 4/6 of this figure is shaded in. Let's go over here. We have 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5 equal sections.
Yeah.
5
4
equal
fifths.
sections.
Oh no, 5.
And 1, 2, 3,
what?
4
4
are
fifths,
shaded
huh?
in. So here,
Yeah.
4/5 of this circle is shaded in. Now in this figure, I have 2 equal sections. 2 equal sections. And both of them are shaded in. So 2, and this we would say 2 halves of this figure are shaded in. And once again, if 2 halves are shaded in, that means everything is shaded in. That this represents a whole. Now this one right over here, it might be tempting to say, hey, I have 1, 2, 3, 4 sections, and 1, 2, 3 have been shaded in, so maybe this represents, the red represents 3/4 of the figure. But remember, the sections have to be equal sections, and this red section is way bigger. It actually looks like it's bigger than the other 3 combined. So you do not have 4 equal sections here. So at least based on how it's drawn, you can't say that 3/4 is actually filled in.
I want to see the YouTube comments of this. How do I get the link of this?
I have a square here divided into 1, 2, 3, 4, 5, 6,
Let's see the
7.
comment section. To be recording, right? Yeah, I'm recording.
I have a square here divided into 1.
Sako, that suck. Lol, bro. XD.
This circle represents one whole. This circle right here represents one whole. If we know that, we can answer what fraction of the circle is shaded in blue below. So down here, what fraction is in blue? Let's start back up
2/3
here with
and
the
a whole.
whole. This whole is
3/3.
divided into
the
1,
last figure.
2, 3 equal size pieces. So it's divided into
2/3.
thirds, 3 equal size pieces. And each of those pieces, each of those pie pieces is 1/3, is one of the thirds. So knowing that, let's go down here to these ones and let's see how many of these 1/3 pieces. Here's 1/3, another 1/3, another 1/3 shaded in blue, another one, and another one. So we have
And
1,
another
2, 3, 4, 5 thirds. We have 5
Oh shit, that's a
thirds
wait, what?
shaded
Why did
in
you
blue
combine?
below.
Well, it's Whoa, that's insane, bro. Why did you combine that?
Another one. So we have 1,
5
2,
thirds.
3, 4,
Fraction the circle shaded blue below.
5 thirds. We have 5 thirds
Okay, there's two
shaded in
different
blue
things,
below.
but okay, let's see where this is gonna go.
We're asked to identify the numerator and denominator in the fraction 3 over 4, or 3/4. So let's rewrite this just so it's nice and big. So let me just write the fraction. So we have 3 over 4. 3 over 4. Now, they want us to identify the numerator and the denominator. The numerator. So the numerator is just the number on top. So the numerator is the 3 right there. And then they want us to find the denominator. The denominator is just the number on the bottom. It's the 4. So if they say, what's the numerator? 3. What's the denominator? It's 4, just the number on the bottom. They could have just called this the number on the bottom. They could have just called this the number on top. Now, to think about what this represents, what this fraction represents, you can think of it of 3 out of 4 pieces of a pie. That's how I think about it. So you can imagine the denominator tells us what are we taking a fraction out of, or how many pieces are there. So let's imagine a pie like this. So we could draw it like, well, we could draw it as a square pie. So we could draw it as a square pie. So this is what the denominator represents. This is what the number on the bottom represents. And then 3 says we are representing 3 of those 4 pieces. So this 3 tells us that out of 4 possible ones, I guess you could think of it, we are using 3, or maybe we're eating 3. So you can imagine someone says, I ate 3/4 of a pie. This would be read as 3/4. They're eating the blue portion of the pie if we cut it this way. If we imagine a round pie, it would look like this. Let me draw a round pie. So that is my round pie. Let me cut it into 4 equal pieces, or roughly equal pieces. And if someone says, I ate 3/4 of this pie, where the 3 is the numerator, and then the 4, and you'd read that as 3/4, the 4 is the denominator, they would eat this much of the pie. They would eat 3 of the 4 pieces. They would eat 3 of the 4. So this is 1 piece, this is 2 pieces, and this is 3 pieces. So you can imagine the 4, the denominator represents the total number of pieces in the pie, and then the 3 represents how many of those we ate.
Oh, okay. Which figures are divided into equal parts? Which circles have 1/8 of the area shaded? No. Yep. No. 2 pieces. Is each piece equal to 1/2 of the pizza? Yeah, man. Which figures are divided into equal parts? This figure is divided, and this one as well. Which circles have 1/4 of their area shaded? This was 1/4 of their area shaded. Spots was this? No. Which figures are divided into equal parts? For sure, it's this one only. Yeah, let's go. Skills proficient. Let's do the next one. Recognize fractions. The large rectangle is equal to 1/4. Which fraction of the rectangle is shaded? Before it's 4 halves, not 4/4. 4. Wait, what? 4/6. Oh shit, it isn't 6. I need it. Each large rectangle is equal to 1/4. Which image is shaded? 3/4. So it's gonna be 3/4. One answer on all. Shit, two answers. Okay, the large rectangle is equal to 1. What fraction of the rectangle is a half? Yeah, oh my god. 4. So 6/8. 6/8. Which circle is equal to 1? Ooh. Which image shows 5/6 shaded? Oh, okay. So 5/6. This one's 6. Oh, choose 2 answers. Wait, what? Where's something? The large rectangle is equal to 1 whole, which fraction is equal to 2/3, right? 2/3 whole. Okay, third practice. What does 6 represent in 6/4? The number of parts we are counting. The number of equal parts in the wholes. The number of equal parts in one whole. Holy shit, what the fuck? This is insane. What the hell is this? The number of parts we are counting. This is the number of parts, right? 4. We are counting the number of equal parts in all the wholes. All the wholes. So I think this one in one whole, all the wholes. So I guess A is the 4 thing, and this is just for the one of the whole. So this one's gonna be A. Are you kidding me? What the hell? Yo, what is this? So my first reasoning was correct. But still tricky. Number equal parts in all the wholes. Oh, if I say equal parts in all the wholes. Yeah. What does the denominator of the fraction of the 8 mean? Oh shit. What does the number of the fraction tens, the number 10/6 mean? Numerator. 10 parts per whole, no. Not 10 parts. Oh, okay. The number of parts in one whole. What does the denominator of the fraction 2/6 mean? What does the denominator? There are 6 parts per whole. What is the numerator? There are 3. We are counting 3 parts. Yeah. I have to try again. What does 8 represent? The number of parts in one whole. What does 0 represent it to? It's the number of parts we are counting. What is the denominator of the fraction 3 halves mean? Denominator. We are counting 2. No, there are 2 parts per whole. What is the numerator of the fraction 1/8 mean? We are counting 1 part. What does 3 represent in 5/3? It's the parts in one whole. What does 0 represent in 3/8? It's the number of parts we are counting. What does the denominator of the fraction 2/3 mean? It's the number of parts per whole. Yeah. Fractions and contents. Okay. I think that's gonna be one word problem, right? Okay. Brian ate 5 pieces of pie. The pie was cut into 6 equal pieces. What fraction of the pie? 5/6. Mrs. Jones ordered 5 cheese pizzas and 1 pepperoni pizzas. She ordered a total of 6 pizzas. What fraction of pizzas are cheese? So there are 5/6 of them are pizzas. Juanita cut her cheese into 4 equal pieces. She gave 2 pieces to her brother. What fraction did the piece take? It's gonna be 2/4. There are 3 balls outside during recess. Two of the balls are orange. What fraction ball of the balls are orange? Here, 2/3. Cool. Fractions on a number line. Wow, this looks...
We've already seen that if we take a whole, and in this example, the whole is this entire green circle, and if we were to split it into 5 equal sections, 1, 2, 3, 4, 5, so we split it into 5 equal sections, and if we were to select one of those 5 equal sections, so let's say we select this section right over here, that we have selected 1/5 of the whole, one out of the 5 equal sections. We could do the exact same thing on a number line. Everything we've been doing so far has to deal with shapes, but we could do the exact same idea on a number line. So let me draw a number line here. So let me draw it pretty big so we get a sense of things. So we'll go all the way to there. And let's say that this is 0, this is 1, and this is 2. And of course, we could keep going if we had more space to 3, 4, and on and on and on. And what I want to do, instead of taking a circle and dividing it into 5 equal sections, I want to take the section of our number line between 0 and 1 and divide it into 5 equal sections. So let me see if I can do this. So 1, 2, 3, 4, 5. That looks pretty good. I'm drawing it as exact as I can with my hand. But let's just assume these are 5 equal sections. So what would happen, what would you think would be a good label for this number right over here? Well, it's the exact same idea. Between 0 and 1, I've traveled 1 out of the 5 equal sections towards 1. And actually, let me make it a little bit neater than that. Make the equal sections look a little bit better. 1, 2, 3, 4, 5. And what we're thinking about is this. What should we call this number here? This number is clearly between 0 and 1. It's clearly closer to 0. And we've gone 1 out of the 5 equal sections towards 1. Well, it makes complete sense that, well, look, we had 5 equal sections here. 5 equal sections here. And we've traveled one of them towards 1. So we should call this number right over here 1/5. So when we're talking about a fraction, 1/5, it's not just talking about, hey, what part of a pizza pie have I eaten or something like that. This is actually a number. This is a number, and we can actually plot it on the number line. Now you might say, okay, well that's fair about 1/5, but what about all these other slashes? What numbers would we call that? Well, we can make the same, it's the exact same idea. If up here, instead of shading in 1 out of the 5 equal sections, if I shaded in 2 of the 5 equal sections, then I wouldn't say this is 1/5 anymore. I would say that this is 2/5. And so if I go 2 of the equal sections towards 1, then I should call this number right over here, I should call this 2/5. And I could keep going. This right over here should be 3 over 5. This right over here, I've gone 1, 2, 3, 4 out of the 5 sections towards 1. So I could call this 4/5. And I could keep going. I could call this right over here. I've traveled 5 out of the 5 equal sections towards 5. So I could call this right over here 5. Let me do that in
And
red
look,
color.
we have
I could call this right over here 5 over 5. You might say, hey, wait, but 5 over 5, we've gotten to 1. And that's exactly right. If I were to shade in 5 things over here, let me do that a little bit cleaner. If I were to shade in 5, that's not the color I want to use. If I were to shade in 5 things over here, we've already seen that shading in 5 things, so if this is, let me make this a little bit neater. If this is now 5 over 5, or 5/5, we've already seen that this is a whole. And over here, if we've traveled 5/5 of the way towards 1, we've gotten to the whole 1. 5/5 is the exact same thing. 5/5 is the exact same thing as 1. It is equal to a whole. We're on the fractions on the number line exercise on Khan Academy, and they ask us to move the orange dot to 3/4 on the number line. Change the number of divisions to create tick marks on the number line. So let's see what's going on here. So I have the space from 0 to 1 on the number line. And if I want to move it to 3/4, what I would first want to do is divide the space between 0 and 1 into fourths, into 4 equal sections. So I would want to have 4 divisions here. And there you have it, 4 divisions. I typed in the number 4 and they have 4 equal divisions.
Cool.
1, 2,
It's pretty
3,
sick.
4. And so this is going to be a fourth, that's another fourth, that's another fourth, and that's another fourth. What we care about is 3 fourths. So once again, that's 1 fourth. This would be another fourth, getting us to 2 fourths. And then this would be another fourth, getting us to 3 fourths. So there you have it. That is 3 fourths on the number line.
Cool. Okay. So I guess we're up to the practice section. Am I recording? Yeah, I'm 30 minutes in. Oh, my face is huge. My haircut sucks. Not my haircut. I haven't had a haircut. It's quarantine time. Which point is at 1/4 of the number line? Yo, wait. Oh shit. Oh, okay, this is 1, so it's gonna be 1/4. 1 of the fourths. Give me A. What fraction is located at point A on the number line? 1, 2, 3, 4, 5, 6. Yeah, it's gonna be 4, 6, right? Which point is at 7, 8 on the number line? Ah, it's gonna be C. Wait, what? Oh shit, this is 8 equal parts. Oh my god. Of course, it's 8. I made a mistake. I'm an idiot. I'm gonna retest this. I'm an idiot. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. After I take this, I didn't fully understand it. I'm an idiot. Which point is at 2/6 on the number line? Oh, it's gonna be B. What fraction is located? It's 1/3, man. Which point is at 3/8 on the number line? Oh, it's A. Gonna be 2/3. Fractions to number line. Move the dot to 5, 6 on the number line. First change the number of division to create. Tick marks on number 6 and 1, 2, 3, 4, 5. Which point is at 7, 8 on the number line? 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's gonna be. What fraction is located at point A on the number line? Oh, it's 3/4. Alright, we're gonna have 8. What if I do 80? Oh shit. 12. Let's do 8. First change the number of divisions. Let's go to 5, 2, 3, 4, 5. And we have Philip over. Yeah, that's correct. 1, 2, 3, 4, 5. Yeah. Which point set 2/3 on the number line? This one's at 2/3. What fraction is located at point A? 2, 3, 4, 5, 6. 5, 6. 4. We move here. Okay, cool. Next. Let's go. What number is at point A? It's gonna be 1/3. Okay, 8s. 1 of the 8s. Point 8. Okay. Wait, what? 4, 2. It's pretty insane. I guess it's 1/2. Whoa, it's insane, bro. Fractions greater than 1 on the number line. Okay, this is gonna be hard. Which point is at 2/5 on the number line? Oh shit, this one's pretty hard. So each we have 2 in each hole, and then we can do 5. So I guess this must have 1, 2, 3, 4, 5. What fractions look at point A? Oh my gosh, what is this supposed to be? Holy shit, this is hard. Oh, we actually have the thing. So 1, 2, 3, 4. 1, 2, 3, 4. 6, 4. Okay, cool. Move the dot to 4/3 of the number line. Okay. Which point is at 3/4 on the number line? This one's no, the 3/4, 4/3. Okay, cool. Start quiz. What number is at point A? Wow. Okay. This is the fourth, so it's gonna be 1/4. Each large rectangle is equal to 1. Oh. Which image shows 2/6 shaded? This is 2/6 and this is 2/6 as well. What fractions located point 8 on the number line? Oh wow, it's hard. It's from 7/3. Which square sub 1/6 of the area shaded? Oh, choose all answers that apply. What is the numerator of the fraction? Numerator fraction. We are counting 4 parts. Which point is at 2/3 on the number line? 2/3? Oh. Oh, it's B. Human divided his clay into 4 equal parts. He made clay animals out of the 3 parts. What fraction of the clay did Yuma use to make clay? Oh, right here, folks. Okay, sick. I haven't made a mistake. That's cool.
So I've got a whole pizza here, and let's say that I were to cut it into 2 equal pieces. So let me cut it right over here into 2 equal pieces. And let's say that I ate one of those 2 equal pieces. So let's say I ate all of this right over here. What fraction of the pizza have I eaten? Well, I took the whole and I divided it into 2 equal pieces, and then I ate one of those pieces. And then I ate one of those pieces. So I ate 1/2 of the pizza. Now let's imagine that instead of cutting that pizza into only 2 equal pieces, let's imagine instead that I decided to cut it into 4 equal pieces. So let's draw that. So 4 equal pieces. So I could cut it once this way, and then I could cut it once this way. And so here I have 4 equal pieces. 4 equal pieces. But let's say that I want to eat the same amount of pizza. How many of these 4 equal pieces would I have to eat? I encourage you to pause the video and think about that. Well, I would eat this piece. You could imagine me eating this piece and this piece right over here. I've eaten the same amount of the pizza. Each of these pieces, you could imagine, got cut into 2 pieces when I cut the whole pizza this way. And so now I have to eat 2 slices of the 4 as opposed to 1 slice of the 2. So I just ate 2 out of the 4 slices. So even though I'm using different numbers here. Here I'm using a 1/2, and here, or 1 in the numerator, a 2 in the denominator. Here I'm using a 2 in the numerator and a 4 in the denominator. These 2 fractions represent the same quantity. I ate the same amount of pizza. If I eat 2/4 of a pizza, if I eat 2 out of 4 equal pieces, that's the same fraction of the pizza as if I eat 1 out of 2 equal pieces. So we would say that these 2 things are equivalent fractions. Now let's do another one like this. Instead of just dividing it into 4 equal pieces, let's divide it into 8 equal pieces. 8 equal pieces. So now we could cut once like this. So now we have 2 equal pieces. Cut once like this. Now we have 4 equal pieces. And then divide each of those 4 pieces into 2 pieces. So we'll cut those in So here we have, so let's see, I want to make them equal pieces. Those don't look as equal as I would like. So that looks more equal. And then that looks reasonably equal. So now how many equal pieces do I have? I have eight equal pieces. I have 8 equal pieces. But let's say I wanted to eat the same fraction of the pizza. So I could eat all of these pieces right over here. Well, how many of those 8 equal pieces have I eaten? Well, I've eaten 1, 2, 3, 4 of those 8 equal pieces. And so once again, this fraction, 4 of 8, or 4/8, is equivalent to 2/4, which is equivalent to 1/2. And you might see a little bit of a pattern here. Going from this scenario to this scenario, I got twice as many equal slices. Because I had twice as many equal slices, I needed to eat 2 times the number of slices. So I multiplied the denominator by 2, and I multiplied the numerator by 2. If I multiplied the numerator and the denominator by the same number, then I'm not changing what that fraction represents. And you see that over here. Going from 4 slices to 8 slices, I cut every slice, I turned every slice into 2 more slices. So I had twice as many slices, and then if I want to eat the same amount, I have to eat twice as many pieces. So all of these, 1/2, 2/4, 4/8, and I could keep going. I could do 8/16, I could do 16/32. All of these would be equivalent fractions. Let's think about what fraction of this
Mic test.
This grid is actually shaded in pink. Let's think about what fraction of this grid is actually shaded in pink. So the first thing we want to think about is how many equal sections do we have here? Well, this is a 1, 2, 3, 4, 5 by 1, 2, 3 grid. So there's 15 sections here. You could also count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 equal sections here. There are 15 equal sections here. And how many of those equal sections are actually shaded in this kind of pinkish color? Well, we have 1, 2, 3, 4, 5, 6. So 6/15 is shaded in. But I want to simplify this more. I have a feeling that there's some equivalent fractions that represent the exact same thing as 6/15. And to get a sense of that, let me redraw this a little bit, where I still shade in 6 of these rectangles, but I'll shade them in a little bit in one chunk. So let me throw in another grid right over here. And let me attempt to shade in the rectangles as fast as possible. So that is one rectangle. I'll even make I can make my thing even bigger. All right, 1 rectangle, 2 rectangles.
This thing should be divided.
2 rectangles, 3 rectangles, 3 rectangles, halfway there. 4 rectangles, 4 rectangles, 5 rectangles, shaded in, and now 6 rectangles. 6 rectangles shaded in. So this right over here, what I just did, this is still 6 rectangles of 15 of the 15 rectangles are shaded in. So this is still 6/15. These are representing the same thing. But how can I simplify this even more? Well, when you look at it numerically, you see that both 6 and 15 are divisible by 3. In fact, their greatest common factor is 3. So what happens if we divide the numerator and the denominator by 3? If we do the same thing to the numerator and the denominator, we're not going to be changing the value of the fraction. So let's divide the numerator by 3 and divide the denominator by 3. And what do we get? We get 2 over 5. Now, how does this make sense? How does this make sense in the context of this diagram right here? Well, here we start off with 6 shaded in. You divide by 3, you have 2 shaded in. So what you're essentially saying, hey, let's group these into sections of 3. So let's say that this right over here is 1 section of 3. This is 1 section of 3 right over here. So that's 1 section of 3. And then this is another section of 3 right over here. And so you have 2 sections of 3. And actually, let me color it in a little bit better. So there's 2 sections of 3. And if you were to combine them, this right over here is one sections of, and you divide by 3 next to this diagram right here. Now, how does this make sense? How does this make sense in the context of this diagram right here? Well, here we start off with 6 shaded in. You divide by 3, you have 2 shaded in. So what you're essentially saying, hey, let's group these into sections of 3. So let's say that this right over here is one section of 3.
Oh, okay.
This is one section of 3 right over here. So that's one section of 3. And then this is another section of 3 right over here. And so you have two sections of 3. And actually, let me color it in a little bit better. So you have 2 sections of 3. And if you were to combine them, it looks just like this. It looked just like this. Notice it's covering the exact same area as your 6 smaller ones did. And then how many equal sections of this size do you have on this entire thing? Well, you have 5 equal sections. So let me go to, because this is one section of 3 right over here. This is another section of 3. And then this is another section. This is another section of 3. So notice you're covering the exact same area of the original thing. You're covering 2 out of the 5 equal sections. So 2/5 and 6/15 are equivalent fractions. So if you want to say what fraction of this is covered in the simplest form, you would say 2/5. So this hexagon right over here, the whole thing is filled in with this pink color. So we'll say that this represents one whole. The whole thing is filled in. Now what I want you to think about is which of these other hexagons have 2/3 filled in. So our goal is to identify the hexagons that are 2/3 filled in. So pause the video now. So I assume you have given a go at it. You have tried to determine which of these are 2/3 filled in. Now let's work on this together. So when you're thinking in terms of thirds, and here we're thinking in terms of 2/3, literally 2/3, what we think about is dividing things into 3 equal sections. So let me see if I can draw a hexagon fairly well. So let me draw the hexagon. And I'm going to try to split it up into 3 equal sections. Whoops. I'm going to try to split it up into 3 equal sections. So this is the center of the hexagon right over here. And so maybe that's one of the equal sections. And then if I do one more line, I've split it up into 3 equal sections. 1, 2, 3. And it's actually kind of neat the way that it's drawn. It looks like a 3-dimensional cube, but that was not my intent. My intent was to draw a hexagon. So let me just... So each of these is a third. Actually, I could write this. That's 1/3. That's 1/3. And this is 1/3. What we care about is 2/3. So 2 of these 1/3. And so let me clean this up a little bit. So I would fill in 1 of the 1/3 and then 2 of the 1/3. And this right over here, this hexagon that I've just drawn now has 2/3 of it filled in. Now I know what you're thinking.
Shit,
all right, Sal, that would have been pretty straightforward if these were divided into thirds, but these are not divided into thirds. Each of these are divided into 1, 2, 3, 4, 5, 6 equal
4
pieces.
sixths. Why did it say the third one?
Into sixths. How do we figure out how many of the sixths should be filled in order to have the same thing as 2/3? Well, I would tell you, don't worry too much. All we have to do is we can redraw this, or we can do a little bit of work here to split this into, instead of 3 equal sections, we can split into 6 equal sections. Well, how would we do that? Well, we take each of those 3 equal sections and then split them into 2 equal sections. So this one right over here, I could split this into 2 equal sections. This one right over here, I could split into 2 equal sections. This one right over here, I can split into 2 equal sections. So I had 3 equal sections before. Now each of them has been split into 2, so now I have 6 equal sections. So now, the way I've drawn it, I'm dealing with sixths. And how many sixths represent the same fraction as the 2/3 did? Well, I still have my shaded area. I have 1, 2, 3, 4 sixths. So 4 sixths is the same thing as 2/3. Or another way to think about it any of these that have 4 out of the 6 equal sections filled in, that means that 2/3 of the sections are filled in, or I could say
Yeah, it's
that
the second,
2/3 of the
fourth,
hexagon
and the
is
last
filled in.
one.
So let's just look at these.
Wow,
So
this
this
is
one, we
crazy.
have
This is
one. Let me
insane.
do a color that has a little more contrast. So we have 1, 2, 3, 4 out of the 6 is filled in. 4/6 are filled in. That's the same thing as 2/3.
I'm
So
clearly
this
an idiot.
represents 2/3. This one only has 2 of the 6 filled in, so it's not 4/6, which has to be 2/3. This is 2/6. We want 2/3. This one is 1, 2, 3, 4. 4 of the 6 are filled in, so this is 2/3. So I will put a square around that one. And this one has 1, 2, 3, 4 of the 6 filled in. So this is 4/6, which we've already figured out is the same thing as 2/3. And we're done. What I want to do in this video is really digest the idea that if we have some fraction, as long as we multiply the numerator and the denominator of the fraction by the same number, that we're going to have an equivalent fraction. So let's think about that. Let's say we multiply the denominator here by 2. Let's say we multiply the denominator here by 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, so here our denominator will be 12. If our numerator here is 4, well, we've got to multiply by 2 again. Multiply our numerator by 2 to get 8. So I'm claiming that 8/12 is the same fraction
I want to
as
start this.
4/6. And what I want to do in this video is really digest the idea that if we have some fraction, as long as we multiply the numerator and the denominator of the fraction by the same number, that we're going to have an equivalent fraction. So let's think about that. Let's say we multiply the denominator here by 2. Let's say we multiply the denominator here by 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, so here our denominator will be 12. If our numerator here is 4, well, we've got to multiply by 2 again. Multiply our numerator by 2 to get 8. So I'm claiming that 8/12, if our numerator here is 4, the denominator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, that we're going to get an equivalent 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent 2. Denominator have a numerator and the denominator. That if we have some fraction, as long as we multiply the what I want to do in this video is really digest the idea that if we have some fraction, as long as we multiply the numerator and the denominator of the fraction by the same number, that we're going to have an equivalent fraction. So let's think about that. Let's say we multiply the denominator here by 2. Let's say we multiply the denominator here by 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, so here our denominator will be 12. If our numerator here is 4, well, we've got to multiply by 2 again. Multiply our numerator by 2 to get 8. So I'm claiming that 8/12 is the same fraction as 4/6. And to visualize that, let me redraw this whole. But instead of having 6 equal sections, we now have 12 equal sections. So each of the 6 we can turn into 2. That's essentially what multiplying by 2 does. We now have twice as many equal sections. Now that we have twice as many equal sections, literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many of them are actually shaded in yellow? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. 8/12. And there's no magic here. If we have twice as many sections, we're going to have to shade in twice as many of them in order to have the same fraction of the whole. And it goes the other way too. This isn't just true with multiplication. It's also true that if we divide the numerator and the denominator by the same quantity, that we are going to have an equivalent fraction. So that's another way of saying, well, what happens if I were to divide by 2? So if I were to divide by 2,
sick.
so let me divide by 2. I'm going to have half the number of equal sections, or I will only have 3 equal sections. And I'm claiming if I do the same thing in the numerator, that this is going to represent the same fraction. So 4 divided by 2 is 2. So I'm claiming that 2/3 is the same fraction as 4/6, as the same fraction as 8/12. Well, let's visualize that. So here, this is 6 equal sections, but now we're going to have only 3 equal sections. So we can merge some of these equal sections. So we can merge these two right over here, and we can merge these two right over here, and then we can merge these two right over here. So our whole is it's still the same whole, but now we only have 3 equal sections, and 2 of them are actually shaded in. So these are all equivalent fractions. So the big takeaway here is start with a fraction. If you multiply the numerator and the denominator by the same quantity, you're going to have an equivalent fraction. If you divide the numerator and the denominator by the same quantity, you are also going to have an equivalent fraction. So with that in our brains, let's tackle a little bit of an equivalent fractions problem. Let's think about if someone says, okay, I have 5 over 25, right? And I want to write that as some value. Let's call that value t. Let's call that t over 100. What would t be? Well, we can see in the denominator, to go from 25 to 100, you had to multiply by 4.
Yeah.
So if you want an equivalent fraction, you have to multiply the numerator by 4 as well. So t will need to be equal to 20. So t is equal to 20. 5 over 25ths is the same thing as 20 over 100. But what if someone says, well, 5 over 25 is equivalent to blank, let's say question mark, over 5. Well, now what would you do? Actually, let's do it the other way. Is equal to 1 over question mark. Well, you could say, look, to go get our numerator from 5 to 1, we have to divide by 5. We have to divide by 5 to go from 5 to 1. And so similarly, we have to divide the denominator by 5. So if you divide the denominator by 5, 25 divided by 5 is going to get you 5. So these are all equivalent fractions. 1/5 is equivalent to 5/25, which is equal to 20 100ths.
Visualizing equivalent fractions. Fractions equal fractions. Fractions equivalent if they are equal percent symbol mark. Let's do example. Oh, crap, symbol 8 of 8 fourths. First, we can draw 1/2 and we design the same whole 8ths. We shade a whole to show a fraction equal to 1/8. We shaded 4 of the 8 sections. So 1/2 is equal to 4/8, number 1. Let's visualize equivalent fractions in number. Number line equivalent, and they are again the same point on each number line. First, we can show a 3/5 on a number line. Yeah, it's pretty hard. Okay. Why is this 3/5? This is from 0 to 1 is divided into 5, so third take marks a 3, third fifth, so 3/5. So let's divide our number line to tenths and see what fractions get at the same point. Wow. 6/5 and 3/5 are located at the same point on the number line. Wow. So 3/5 equals 6/10. Practice. Oh wow, that's pretty hard. 2/5 can be like 1, 4. Okay. 3. And 6. Move the dot graph on 90 on the number line. Guess this one. How is it? Where's the 6 divider? This could be this one. This is the 6. It's going to be 9. Move the dot to the graph fraction equal to 9 to the number line. Oh shit, it's insane. Oh, this one's pretty hard. Fractions are equivalent if they are equal or represent the same amount. Want to learn about visualizing equivalent fractions? Let's start finding equivalent fractions in multiplication. What number could replace a below? It's going to be 6. No, that's 6. Go from 3 to 4, so 2 to 8, it's going to be 8. First we need to figure out by 4. Then multiply them with the same amount. So we can replace the A with an 8. I want to, okay. Number to replace R, it's going to be 4. Third. Oh, it's in the 3. Cool. Yeah. Wow, okay, I'm not just gonna say it's analyst 3, but let's see in the visualization part. Which speed shares a new area to 8/12. Oh. Whoa, 8/12 and 1/3. Yeah. Think about how we can fill each circle below to help us find an equivalent fraction. Oh wow, okay. 4 8s, so that should be 4ths. Oh, it's per sec. We should find a fraction equivalent to 1/4. It's to 8. What value W makes the equation true? Let's jump to 2, so it's gonna be 8. Sure, fractions are equivalent to 6/8. 6/8. Let's see. It's going to be 2/3, right? I mean, yeah, it's 3/4 actual. So if I divide by 2, we get okay. Number to replace P below 4/8/3. Simplify fractions. Write in simplest form. Okay. So 14 is the vis. What's their common? Oh shit, it's gonna be like for 7. So it's gonna be 2/5. 44. So we have it's gonna be 20 to 6. We can still have that. We have 3/11. 11/3. Alright, let's put this away 6. Let's say I don't know 3/9, right? Oh shit, it's 1/3. Right, 16 remember simplest form. Okay, 16 is divisible by 4. We have 4, 6. Can still divide this by 2. We have 2/3. Yeah. Write 80 and 16 simplest form. Okay, this is both by 8. So 10, 2, or 5. Or just 5, right? Just right, but I'm gonna do 5/1. No way. No way, no way, no way, no way. It's 10, 2, and 5/1. Or 10, 2. Wait, what? Oh shit, that is divided by 8. Oh no. Oh shit, I'm wrong. I'm stupid. I divided the numerator by 10. It shouldn't be 10. Oh, this is by 4. So I have 20 in 4. Or just 5. Oh no. Right, 26 in simplest form. Okay, it's gonna divide it by 3. 13. While 26 divided by 3, if it's 8, it's gonna be 24, 7, 28. No. Divided by 3. Or it's the simplest form. Let's try it. Let's try it on 699. Oh no, of course not. Can I divide 39 by half? For sure not. You need to be an odd number, not an even number. Be able to do that by half. Okay. I can. Okay. What's a multiple? I can go 6. 5. No. 6 is 24 and 30. 7, 20. Oh shit. This isn't. It's really hard, man. Why 26 by 3? 8 is 24 and 9 is 27. Wow, this is really hard. What is something divisible by 39? Something multiple. Let's do 9 with 36. By 4, we're not getting 39. Oh shit. Okay, so 30 definitely can go. And then it's gonna be 13. 1, 13. Just 10, and then 3 more, 13. Yeah. Oh shit, I'm an idiot. I'm an idiot. I know I can do 13. Why? I had a brain fart. A massive brain fart. Okay, it's gonna be divided by 15. 4/3. Oh shit. What? What? Oh fuck. It's not 4/3? If we divide it by 15, we get 4. Divide by 15, we get. No, we got 3, 2, man. Oh shit. Okay, that's. No. We kind of failed that one. Okay, so run simplest form. It's 1/3. Okay, this one's definitely by. No, this is by 7. 7 times 6. It's not. It's 54. 7 times 6 is 54, right? Right? Ah, it's 9. It's 9 times 7 is 54. 7 times 6 is 42. So 49. It's gonna be 7. 49 divided by 7 is gonna be 7. It's gonna be 8, 7, I guess. 7 times 8 is 56, of course. Right, 45 and 27. 45, 27 in simplest one. Okay, this is in 9. So 5 and 3. Did I simplify that? No, not anymore. Okay, this is definitely in thirds. So 30 is gonna be 10. God, I'm kind of confused. Oh, we by 6. So we have 3 fifths. Oh, it's 1/10. One to 15. We have 2 thirds. Right, 81/45. Oh shit. It's 9 fifths. Can I simplify this? No, I can't. Okay, equivalent fractions. Move the dot to graph 912 on the number line. What fraction is equal to point A? 1, 2, 3, 4, 5, 6. That's 4, 6. 4, 6, or 2 thirds. Use the number line below to help complete the equation. Oh shit, this is insane. This is 8. Move the dot to graph 5 thirds on the number line. Move the dot to the graph. Okay. 5 thirds. Oh, so this is 6 thirds. So this is 3, 3, then it's 5 thirds. Oh, this is 5 thirds. And it's probably this one, so. Okay, so 6 twelves. Oh shit, I have to count this. 6, 7, 8, 9, 10. Obviously, yeah. Double chunk. Okay, comparing fractions. Oh, this one's gonna be hard.
When you write a fraction, there are actually words for the top number and the bottom number. And the words are a lot more fancy than the word top number and bottom number. What mathematicians typically use is the word numerator for the top number, and denominator for the bottom number. Denominator for the bottom number. Now what I want to do now that we know that the top number is the numerator of the fraction, the bottom number is the denominator, I want to compare pairs of fractions that have either the same denominator or the same numerator. So let's look at this first pair. I want to compare 4/7 to 3/7, and I have 2 wholes right over here. They're the same whole, and I've divided them into 7s. I've divided them into 7 equal chunks. And I want to see what's larger, 4/7 or 3/7. So what I can do is I can fill in 4/7. Let me select 4 out of the 7. So that's 1, 2, 3, 4. And the fact that trying to even get to 4/7, I had to have 3/7 first gives you a good clue that 4/7 is probably larger, or it is larger. But now let's color in 3/7 just so we can compare. So 1, 2, 3/7. And so it's pretty clear that on the left-hand side we are shading in more of the whole than on the right-hand side. So 4/7 represents a larger fraction, more of the whole than 3/7. And the way that we can state that comparison mathematically is with the greater than symbol. We can write 4/7 is greater than 3/7. Now the greater than and less than symbols can sometimes be confusing. This is greater than, this is less than. So this is greater than, this is less than. And the way that I remember it is that the greater than symbol, either symbol, the small pointy side is always on the side of the smaller number, and the big open side is always on the side of the larger number. So here, big open side is opening towards the 4/7, small pointy side opening to the 3/7. 4/7 is greater than 3/7. Now what about 3/7 and 3/4? So here I have different denominators, but I have the same numerator. And so I encourage you to pause this video and draw maybe little boxes like this and try to judge for yourself which of these is a larger fraction, represents a larger number.
3/4.
Well, let's color them in. So let's think about 3/7 first, and we actually already drew it here, but I can do it really fast right over here. So that is 3/7. I've colored in 3 of the 7 equal groups. And what would 3/4 be? Well, that's 1/4, 2/4, and 3/4. And so it's pretty clear that 3/4 represents a larger fraction of the whole, that 3/4 is larger or that 3/7 is smaller. So we could write that 3/7 is less than 3/4. So notice, same exact numerator. When I divided it, because this fraction symbol can also be viewed as division, when I have it as more equal groups, or it's a fraction of more equal groups, so 3 out of 7 versus 3 out of 4, this is a smaller number, which makes sense. Now let's compare these two. We have the same denominator, different numerators. 3/4 versus 2/4. Well, 3/4 we've already looked at. We can just shade in 3 of these. So 3 of these fourths. So that's 3/4 right over there. And then 2/4, where we're going to only have 2 of the fourths. 1, 2. So 2/4 is clearly the smaller number. 3/4 is the greater number. So once again, we could write 3/4 is greater than 2/4. And then finally, I encourage you to pause the video. Try to come up with whether 2/4 or 3/6 is a larger number. Well, let's color it in again. We've already seen
the
2/4.
same. They're
We
equal.
just have to color in 2 of our fourths. So let's just color in 2 of our fourths right over there. And then 3/6, we've split our whole into 6 equal sections. 1, 2, 3, 4, 5, 6. We need to color in 3 of them. And as you see, we are coloring in the exact same amount of the whole. These two fractions are equivalent. These are equivalent fractions. 2/4 is equal to 3/6. And as you see here, they're both filling in half of the whole. If we were to just draw the whole and split it only, let me do this in a different color. If we have our whole, and we were to split it only into 2 sections, we are shading in exactly 1 out of the 2 sections. 1 out of the 2 sections.
That's the same with 1/2.
So you could say that 2/4 is equal to 3/6, and they both equal 1/2. They all equal. So 1/2 is equal to 2/4 is equal to 3/6. Let's compare the fraction 4/7 to the fraction 5/7. And what I want you to do right now is to pause this video and think about which of these fractions represents a larger quantity.
5/7.
I'm assuming you've had a go at it, and the one thing that might jump out at you is that they both have the same bottom number, which we call the denominator. They both have a denominator of 7. So one way to think about it, this is literally 4/7. This is literally 5/7. So we could rewrite 4/7 as literally 4 times 1/7. And we can rewrite 5/7 as literally 5 times 1/7. It's 5/7. 5/7. So now if I have 4 of something versus 5 of something, which is going to be a larger quantity? Well, clearly 5 of this 1/7 is going to be more. So 4/7 is smaller, 5/7 is larger. And so what we can do is we can write a less than symbol. And the way that I remember less than and greater than is that the point, the small side of the symbol, always is on the same side as a smaller number. So this could be read as 4/7 is less than 5/7, or that 4 times 1/7 is less than 5 times 1/7. Now let's do another scenario, but instead of having the same denominator, let's have the same numerator. So let's say we want to compare 3/4 versus 3 over, let's say, versus 3/9. Which of these two fractions is a larger number? And once again, pause the video and try to think about it.
3/4.
Well, as as we mentioned, we don't have the same denominator here. We have the same top number instead. Here was the same bottom number, same denominator. Here we're going to have the same numerator. We have the 3 right over there. And we could view 3/4 as literally 3 times 1/4. And we could view 3/9 as literally 3 times 1/9. 3 times 1/9. So we have 3/4 and we have 3/9. So we really just have to think about what's larger, a 4th or a 9th? Well, think about if you start with a whole, think about starting with a whole like this. Larger, a 4th. So we have the 3 right over there. And we could view 3/4 as literally 3 times 1/4. And we could view 3/9 as literally 3 times 1/9. 3 times 1/9. So we have 3/4 and we have 3/9. So we really just have to think about what's larger, a 4th or a 9th? Well, think about if you start with a whole. Think about starting with a whole like this. Think about starting with a whole. Let's draw and let me make a hole right over here. A hole right over here. So the same sized hole. A 4th is literally taking the whole and dividing it into 4 pieces, while a 9th is taking the whole and dividing it into 9. 9 equal sections, I could say. So let's divide this into 4 equal sections. So my best attempt to hand draw
the
equal
right
sections.
box could be larger than 1/4 if its sizes.
That looks pretty close to 4 equal
humongous.
sections.
10
So
times.
that right over there is
The 1/9
1/4.
of the 10
And
times
let me
larger
draw
size
9th
box
here.
would be
First,
larger
put
than
this into
1/4.
3 equal sections. So those would be third, and then split each of those into 3 equal sections. So this is my best attempt at that. At hand drawing 9 equal sections, splitting the whole into 9 equal sections. So when you see here, and you might have already realized this, if you divide something into 4 equal sections, each section is going to be bigger than if you divide it into 9 equal sections. A 9th is smaller than a 4th. A 9th is smaller than 1/4, so 3/9 is going to be smaller than 3/4. So once again, when you want to do less than or greater than, you want to put the point, the small side of the symbol, on the same side as the smaller number. So it would look like this. And this is the greater than symbol because you're literally, what you have on the left is the larger number. 3/4 is greater than 3/9. And if you actually wanted to represent not just 1/4 and 1/9, we could actually color it in. 3 times 1/4, well, that's 1, 2, 3. While 3 times 1/9 or 3/9 is 1, 2, 3. And when you look at it that way, it's pretty clear. But the important thing to realize is that when the denominator is larger, you're dividing the whole into more pieces, so each piece will be smaller. So making the denominator larger makes the fraction smaller. Making the numerator larger makes the fraction larger.
Determine whether 30/45ths and 54/81sts are equivalent fractions. Well, the easiest way I can think of doing this is to put both of these fractions into lowest possible terms, and then if they're the same fraction, then they're equivalent. So 30 over 45. 30 over 45. What's the largest factor of both 30
15.
and 45? The one let's see, 15 will go into 30. It'll also go into 45. So this is the same thing. 30 is 2 times 15. And 45 is 3 times 15. So we can divide both the numerator and the denominator by 15. So if we divide both the numerator and the denominator by 15, what happens? Well, this 15 divided by 15, they cancel out. This 15 divided by 15 cancel out. And we'll just be left with 2/3. So 30/45 is the same thing as 2/3. It's equivalent to 2/3. 2/3 is in lowest possible terms, or simplified form, however you want to think about it. Now let's think about 54. Let's try to do 54 over 81. 54 over 81. Now let's see. Nothing really jumps out at me. Let's see. 9 is divisible into both of these. We could write 54 as being 6 times 9. And 81 is the same thing as 9 times 9. You can divide the numerator and the denominator by 9. So we could divide both of them by 9. 9 divided by 9 is 1. 9 divided by 9 is 1. So we get this is equal to 6 over 9. And let's see, 6 is the same thing as 2 times 3. 9 is the same thing as 3 times 3. We could just cancel these 3's out, or you could imagine this is the same thing as dividing both the numerator and the denominator by 3, or multiplying both the numerator and the denominator by 1/3. These are all equivalent. I could write divide by 3 or multiply by 1/3. So let me write divide by 3. Let me write divide by 3 for now. I don't want to assume you know how to multiply fractions, because we're going to learn that in the future. So we're going to divide by 3. 3 divided by 3 is just 1. 3 divided by 3 is 1, and you're left with 2/3. So both of these fractions, when you simplify them, when you put them in simplified form, both end up being 2/3. So they are equivalent fractions.
No, that was pretty insane.
Use less than, greater than, or equal to compare the two fractions 21/28 or 21 over 28 and 6/9 or 6 over 9. So there's a bunch of ways to do this. The easiest way is, if they had the same denominator, you could just compare the numerators. Unlucky for us, we do not have the same denominator. So what we could do is we can find a common denominator for both of them and convert both of these fractions to have the same denominator and then compare the numerators. Or, even more simply, we could simplify them first and then try to do it. So let me do that last one, because I have a feeling that'll be the fastest way to do it. So 21 over 28, you can see that they are both divisible by 7. So let's divide both the numerator and the denominator by 7. So we can divide 21 by 7, and we can divide, so we make the numerator, and we can divide the denominator by 7. We're doing the same thing to the numerator and the denominator, so we're not going to change the value of the fraction. So 21 divided by 7 is 3, and 28 divided by 7 is 4.
LCM.
So 21/28 is the exact same fraction as 3/4. 3/4 is a simplified version of it. Let's do the same thing for 6/9. 6 and 9 are both divisible by 3. So let's divide them both by 3 so we can simplify this fraction. So let's divide both of them by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So 21 over 28 is 3/4. They're the exact same fraction, just written in a different way. This is the more simplified version. And 6/9 is the exact same fraction as 2/3. So we really can compare 3/4 and 2/3. So this is really comparing 3/4 and 2/3. And the real benefit of doing this is now this is much easier to find a common denominator for than 28 and 9. Then we would have to multiply big numbers. Here we can do fairly small numbers. The common denominator of 3/4 and 2/3 is going to be the least common multiple of 4 and 3. And 4 and 3 don't share any prime factors with each other. So their least common multiple is really just going to be the product of the two. So we can write 3/4 as something over 12, and we can write 2/3 as something over 12. And I got the 12 by multiplying 3 times 4. They have no common factors. Another way you could think about it is 4, if you do a prime factorization, is 2 times 2. And 3, it's already a prime number, so you can't prime factorize it anymore. So what you want to do is think of a number that has all of the prime factors of 4 and 3. So it needs 1, 2, another 2, and a 3. Well, 2 times 2 times 3 is 12. Either way you think about it, that's how you get the least common multiple, or the common denominator for 4 and 3. Well, to get from 4 to 12, you've got to multiply from 4 or the common 12. Either way you think about it, that's how you would get the least common multiple, or the common denominator for 4 and 3. Well, to get from 4 to 12, either way you think about it, that's how you would get the least common multiple, or the common denominator for 4 and 3. Well, to get from 4 to 12, you've got to multiply by 3. So we're multiplying the denominator by 3 to get to 12. So we also have to multiply the numerator by 3. So 3 times 3 is 9. Over here, to get from 3 to 12, we have to multiply the denominator by
4.
4.
Wow,
So we
9,
also have
12,
to
and
multiply
8,
the numerator
4.
by
So
4.
the left
So
one
we
is
get,
larger.
so we get 8.
Use the greater
And so
than
now when we
symbol.
compare the fractions, it's pretty straightforward. 21 over 28 is the exact same thing as 9 twelfths, and 6 ninths is the exact same thing. 6 ninths is the exact same thing as 8 twelfths. So which of these is a greater quantity? Well,
It's 9
clearly we have the same
twelfths.
denominator right now. We have 9 twelfths is clearly greater than 8 twelfths. So 9 twelfths is clearly greater than 8 twelfths. Or if you go back and you realize that 9 twelfths is the exact same thing as 21 over 28, we could say 21 over 28 is definitely greater than, and 8 twelfths is the same thing as 6 ninths, is definitely greater than 6 ninths. And we are done. Another way we could have done it, we didn't necessarily have to simplify that. And let me show you that just for fun. So if we were doing it with, if we started with,
Cross
if we didn't
multiplication.
think to simplify our two numbers first, I'm trying to find a number, a color I haven't used yet. So 21 over 28 and 6 over 9. So we could just find a least common multiple in the traditional way without simplifying first. So what's the prime factorization of 28? It's 2 times 14, and 14 is 2 times 7. That's its prime factorization. Prime factorization of 9 is 3 times 3. So the least common multiple of 28 and 9 have to contain a 2, a 2, a 7, a 3, and a 3. Or essentially, it's going to be 28 times 9. So let's over here multiply 28 times.
What?
Essential of 28, prime factorization of 9 is 3 times 3. So the least common multiple of 28 and 9 have to contain a 2, a 2, a 7, a 3, and a 3. Or essentially, it's going to be 28 times 9. So let's over here multiply 28 times 9.
Heck.
28 times 9.
With the
There's a couple ways you could do it. You could multiply in your head 28 times 10, which would be 280, and then subtract 28 from that, which would be like, what, 252? Or we could just multiply it out if that confuses you. So let's just do the second way. 9 times 8 is 72. 9 times 2 is 18. 18 plus 7 is 25. So we get 252. So I'm saying the common denominator here is going to be 252. 252 and 252. Least common multiple of 28 and 9. Well, to go from 28 to 252, we had to multiply it by 9. We had to multiply 28 times 9. So we're multiplying 28 times 9. So we also have to multiply the numerator times 9. So what is 21 times 9? That's easier to do in your head. 20 times 9 is 180, and then 1 times 9 is 9. So this is going to be 189. To go from 9 to 252, we had to multiply by 28. So we also have to multiply the numerator by 28 if we don't want to change the value of the fraction. So 6 times 28, 6 times 20 is 120. 6 times 8 is 48, so we get 168. Let me write that out just to make sure I didn't make a mistake. So 28 times 6 is 8 times 6. 8 times 6 is 48.
That's 168.
48. 2 times 6 is 12, plus 4 is 16. So right, 168. So now we have a common denominator here. And so we can really just compare the numerators. And 189 is clearly greater than 168. So 189 over 252 is clearly greater than 168 over 252. Or that's the same thing as saying 21 over 28, because that's what this is over here. The left-hand side is 21 over 28 is clearly greater than the right-hand side, which is really 6 ninths.
What I want to do in this video is order
Holy
these
shit,
fractions
that's
from
hard.
least to greatest. And the easiest way, and the way that I think we
denominators
can be
for
sure we'll get
everything.
the right answer here, is to find a common denominator. Because if we don't find a common denominator, these fractions are really hard to compare. 4 ninths versus 3 fourths versus 4 fifths, 11 twelfths, 13 fifteenths. You can
Same.
try to estimate them, but what you can get you'll be able to directly compare them if they all had the same denominator. So the trick here, or at least the first trick here, is to try to find that common denominator. And there's many ways to do it. You could just pick one of these numbers and keep keep taking its multiples and find that multiple that is divisible by all the rest. Another way to do it is look at the prime factorization of each of these numbers, and then the least common multiple of them will have to have at least all of those prime numbers in it. It has to be composed of all of these numbers. So let's do it that second way, and then let's verify that it definitely is divisible. So 9 is the same thing as 3 times 3. So our least common multiple is going to have at least one 3 times 3 in it. And then 4 is the same thing as 2 times 2. So we're going to also have to have a 2 times 2 in our prime factorization of our least common multiple. 5 is a prime number, so we're going to need to have a 5 in there. And then 12, I'm going to do that in yellow. 12 is the same thing as 2 times 6, which is the same thing as 2 times 3. And so in our least common multiple, we have to have 2 2's, but we already have 2 2's right over here from our 4, and we already have 1 3. We already have 1 3 right over here. Another way to think about it is something that is divisible by both 9 and 4 is going to be divisible by 12, because you're going to have the 2 2's and you're going to have that 1 3 right over there. And then finally, we need to be divisible by 15's prime factors. So let's look at 15's prime factors. 15 is the same thing as 3 times 5. So once again, this number right over here already has a 3 in it, and it already has a 5 in it. So we're cool for 15, for 12, and obviously for the rest of them. So this is our least common multiple, and we can just take this product. And so this is going to be equal to 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 5. 36 times 5. You can do that in your head if you like, but I'll do it on the side just in case. 36 times 5, just so that we don't mess up. 6 times 5 right? is 6 times 5 is 30. 3 times 5 is 15. Plus 3 is 180. So our least common multiple is 180. So we want to rewrite all of these fractions with 180 in the denominator. So this first fraction, 4/9, is what over 180? To go from 9 to 180, we had to multiply the denominator by 20. So let me do it this way. So if we do 4 over 9, to get the denominator of 9 to be 180, you have to multiply it by 20. And since we don't want to change the value of the fraction, we should also multiply the 4 by 20. So we're just really multiplying by 20 over 20. And so 4/9 is going to be the same thing as 80 over 180. Now let's do the same thing for 3/4. 3 over 4. Well, what do we have to multiply the denominator by to get us to 180? So it looks like 45. You could divide 4 into 180 to figure that out. But if you take 4 times 45, 4 times 40 is 160. 4 times 5 is 20. You add them up, you get 180. So if you multiply the denominator by 45, you also have to multiply the numerator by 45. 3 times 45 is 120 plus 15, so it's 135. 135, and the denominator here is 180. Now let's do 4/5. 4 over 5. To get the denominator to be 180, what do you have to multiply 5 by? So 5, let's see, if you multiply 5 by 30, you'll get to 150, but then you have another 30. So you have to multiply it. Oh, actually, we know it right over here. You have to multiply it by 36. Multiply by 36. Well, then you have to multiply the numerator by 36 as well. And so our denominator is going to be 180. Our numerator, 4 times 30 is 120. 4 times 6 is 24, so it's 144 over 180. And then we have only 2 more to do. So we have our 11/12. 11 over 12 is, so to get the denominator to be 180, we have to multiply 12 by, so 12 times 10 is 120, and then you have 60 left, so they have to multiply it by 15. 15 in the denominator and 15 in the numerator. And so this gives us, the denominator gives us 120, and then you have to multiply 12 to do. So we have our 11/12. 11 over 12 is, so to get the denominator to be 180, we have to multiply 12 by, so 12 times 10 is 120, and then you have 60 left, so they have to multiply it by 15. 15 in the denominator, and
Okay, so
15 in the numerator.
5 for that,
And so
60.
this gives us, the denominator gives us 180. And 11 times 15. So
166.
10 times 15 is 150. And then you have one more 15. So it's going to be 165.
Holy shit,
165.
course,
And then
makes
finally,
sense.
we have 13 fifteenths. We have 13 fifteenths. To get to our denominator to be 180, you have to multiply it by 12. We already figured out that 12 times 15 is 180. So to multiply it by 12, that'll give us 180 in the denominator. And so you have to also multiply the numerator by 12 so that we don't change the value of the fraction. We know 12 times 12 is 144. You put one more 12 in there, you get 156. Did I do that right? 12 plus 144 is going to be 156. So we've rewritten each of these fractions, 154. You put one more fraction. We know 12 times 12 is 144. You put one more 12 in there, you get 156. Did I do that right? 12 plus 144 is going to be 156. So we've rewritten each of these fractions with that new common denominator of 180, and now it's very easy to compare them. You really just have to look at the numerators. So the smallest of the numerators is this 80 right over here. So 4/9 is the smallest. 4/9 is the least of these numbers. So let me just write it over here. So this is our ordering. We have 4/9 comes first, which is the same thing as 80 over 180. Let me write it both ways. 80 over 180. Then the next smallest number looks like it's this 135 right over here. So then our next one is going to be the 135. I want to do it in that same color. The next one is going to be that 135 over 180, which is the same thing as 3/4, which is the same thing as 3/4. And then the next one is going to be, let's see, we have the 144 over 180. So this is going to be the 144 over 180, which is the same thing as 4/5. And then finally, or we have two more. And the next is this 156 over 180. So then we have our 156 over 180, which is the same thing as 13 fifteenths. 13 over 15. And then we have one left over, the 165 over 180, which is the same thing. So I want to do that in yellow. We have our 165 over 180, which is the same thing as 11/12. Which is the same thing as 11/12. And we're done. We have finished our ordering. So this is, if you're doing the Khan Academy module on this, this is what you would input into that little box there.
That's a pretty insane process, bro.
Order the fractions from least to greatest. So we have three fractions, and we want to decide which one is the smallest, which one's in the middle, and which is the greatest. So one thing we could do is look at the fractions, think about what they mean, and then estimate.
1/3, 7/10, and 5/6.
7/10, let's say maybe that could represent 7 of your 10 friends are wearing blue jeans. Well, that's most. Most of your friends are wearing blue jeans. And then for 1/3, we could say 1 of your 3 teachers wears glasses. Well, that's not most. If only 1 of the 3 wears glasses, that's not most of the group. So here's a fraction that represents most of the group. Here's one that doesn't. So the most is probably greater. These two we could compare by estimating and see that this one, 7/10, is probably greater than 1/3. But then we get over here to 5/6, and 5 out of 6, well, again, that's most of the group. But is this most of the group greater than the 7/10 most of the group? That gets a lot trickier. So what we can do is we can try to change these fractions to make them easier to compare. So we don't have to compare tenths to thirds to sixths, because those are all different sizes, different size groups, different size pieces. That's tricky to compare. So we want to change these to be the same size. So we need some number, a multiple of 10, 3, and 6, something we can multiply 10, 3, and 6 by to get a new denominator that will work for all of the fractions. One way I like to figure this out is I look at the biggest denominator, which is 10, and I think of its multiples. The first multiple is 10, because 10 times 1 is 10. Can we change thirds and sixths to have 10 as a denominator. Is there any whole number you can multiply 3 times to get 10?
No.
There's not, so we need to keep going. 10 doesn't work. The next multiple of 10 is 10 times 2, which is 20. Again, 3 and 6, is there a whole number we can multiply them by to get 20? Again, no. So 20 doesn't work. How about 30?
Yeah. 30.
Let's see.
Wait.
3, we can multiply 3 times 10 to get 30. So 30 works for 3. How about 6?
Yeah,
6 times 5
6
equals
times
30. So yes,
30.
30 can work to be our common denominator. 30 is a multiple of 10, 3, and 6.
What if I do the prime factorization thing? So it's going to be 5, 2, and 5. Okay. Split 3 already. 6 is 2 and 3. Which we already have. Like, this is 3 and we over 2 here. So 2 times 5 is 10. Then times 3 is 30. Holy
6.
shit. Holy shit.
So let's start converting our fractions to have denominators of 30. We'll start with 7/10. And we want it to have a denominator of 30. So what do we need to multiply by? 10 times 3 is 30.
What?
We always multiply the numerator and
By 3
denominator
as
by
well.
the same number.
I get 21.
So 7 times 3 is 21. So 7/10 is equal to 21/30. These are equal. We've just changed the size of the group. We've changed the denominator so that they will be easier to compare, but we've not changed what portion of the group we're representing. 7 out of 10 is the same portion as 21 out of 30. And then let's keep going with 1/3. Again, we want a denominator of 30, so this time we'll multiply 3 times 10 to get 30. Again, numerator also times 10. 1 times 10 is 10. 10 out of 30 is the same as 1/3. If you have 10 of the 30 people, again, we'll use the wear glasses example, or 1/3. That is the same size of the group, the same portion. And finally, 5/6. What do we need to multiply here to get 30? 6 times 5 is 30. So we multiply the numerator times 5, and 5 times 5 is 25. So now, instead of these original fractions that were tricky to compare, we have much easier numbers to compare. We have 21/30, 10/30, and 25/30. So in this case, the pieces are all 30ths. They're all groups of 30. So this is much easier to compare. We can simply look at the numerators to see what portion of those 30 the fraction represents. So the first 7/10 is the same as 21 out of 30, whereas 1/3 is 10 out of 30. Well, clearly 21 out of 30 is a larger portion of the group than 10 out of 30. So we were right when we estimated up here that 7/10 is larger than 1/3. But then the trickier one over here, now we can see much more clearly 25 out of 30 is the greatest portion of the group. 25 is more than the 10 or the 21. So we can list these now from least to greatest. The smallest is 10/30, which again, remember, is equal to 1/3. So we can put 1/3 is least. And we can cross that off. Next, it's either 21 out of 30 or 25. 21 is less, and that represented 7/10. So we can say 7/10, because 21/30 equals 7/10. And finally, that leaves us with 25/30, which is equivalent to 5/6. So from least to greatest, our fractions are 1/3, 7/10, and then 5/6.
Holy shit. Oh shit, wait, what? Holy crap, this is hard. Let's do the prime factorization bullshit. 4, 2, 5, 2, so 2 times 2, 4, 4, 8, 40 is the LCM. So to get that, we get 40 times 4, we get 48. Well, this one, to get from 8 to 40, to multiply by 5. So 5, right? 45. Holy shit, that's amazing. So clearly, oh, what the fuck? Okay. Clearly, 48 is greater. Oh, okay. Wow, this is greater than 4. Yeah, this 10 half. Okay, it's 10 to 15 half. It's 1 half. Oh, it's gonna be greater. 5, 6. So at least just half. Okay, 5, 6 greater. Order fractions. Practice. Okay. Holy shit. Okay. So we have 73 over 100, and that's gonna be times 10 over 100. And from 5 to become we multiply by 20, 40 over 100. So we have in this order. Okay, so we have 2, 2, and we have 2, 4, 2, 4, which is 2, 2 as well. 2, 2, 2, 2. This one's 2, 4, 2, 2. So we have only have 3, and then times 3. Okay, so 2 times 2, 4, 8 times 3 is 24. Is their LCM? It's true, it's true. So we're gonna go 24 for the first one. For that, we go let's move by 6, so it's gonna be 18. The second one's gonna be 3 multiplied by 3. It's 9. And then this guy for to be 24, we have to multiply by 8. So 2 times 8, it's, oh shit, what am I, 24 multiplied by 8, 16. Holy shit. Okay, so the least is this guy, next is this, and the greater is that guy. Okay. Okay. Oh, I guess 12. So for that to become 12, we have to multiply by 4. Oh no, by 3, so we get 9. And this one, for it to get 12, we have 4. 4, 8. Okay, this is clearly a half. shit. Oh shit, this one's hard. But I'm pretty sure this is correct. Plot 5, 6. 1, 2, 3, 4, 5, 6. Okay, it's 6. Plot 3, 6. Okay, 1, 2, 3. Okay. So clearly 5, 6 is greater than 3, 6. Whoa. Whoa, what? Oh shit, it should be here, right? Oh my fuck. Okay. 3/4, 3/4, 3/8. And clearly 3/4 is larger than 3/8. 7/8. 8/8. So 8/8. Let's try it again. Let's try it again. Let's try it again. Okay, 2/6, and we have 2/4. So 2/4 is greater. Alright, we have 4/6. 2, 3, 4, 5, 6. Okay, then we have 1/6. It's gonna have 6. So it's definitely great. 4/6 is great. One half and 3/2. Wow, okay, it's insane. Ah, what the heck? No. What? 1/2. This is 1/2. Oh shit, it's 4/2. It should be here. Oh my god. Okay, let's try again. Let's try again. Didn't pay attention to the numbers. Okay, 6/8. 2/3. Okay, that's clearly 6. So this is, wait, what? This is 3, 3. So 2/3. 6, 3. You have 4/3. 4/3 great. 4/6 is 4/6. 4/4. Okay, 4/4 is greater than 3/4, and we have 2/4. So it's gonna be 3/4. Let's go. Tom compared 2 12 and 7/6 by first comparing each fraction to 1/2 and 1. 2 12 is less than 1/2. 7/6 is less than 1. 7/6 is less than 1. Are you kidding me? It's fucking greater than 1. Well, green screen that shit. Step 2, bitch. Graph 4/10 and 3 halves on 3/2. 4/10 on the length show. Okay. Let's do 1. Okay, so this is 4/10 and this is 3. And so clearly another one is larger. Okay, our mistake. It's greater than 1, correct? 5/8 is not greater than 1. Graph 2/3 and 5/10. This is 5/8 and this is 3. So 3 is greater than 5/8. Cool. Got it. Onwards. Tom, Vicky, and Anne are eating a cake. The amount they ate is listed below. Vicky ate 2/5 of the cake, Anne ate 2/8 of the cake, and Tom ate 1/4 of the cake. Which statement compares the amounts of cake two friends ate? Tom ate the same amount of cake as Vicky. So Tom ate 1/4 and Vicky ate 2/5. No, it's not right. Anne ate more cake than Vicky. Anne is 2/8 of the cake and Vicky is 2/5. No, 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 no. Tom ate the same amount of cake as Anne. Tom is 1/4. Anne is 2/8. That's correct. Mrs. Smith made a table to show the hair color of the students in her room. Which hair color represents less than 1/4 of the class? Okay. Less than 1/4? Holy shit. Okay. 2/12 is less than 1/4. It's red hair. Oh, okay. Two answers. Which hair color represents 2/6 is not. It's 1/3. 1/3, no. And blonde hair. Yeah. Pam bought different drinks for a party she was drunk. After the party, she had the following drink amounts left over: a half liter of soda, 1/5 liter of soda, and 8/10 liter of apple juice, which simply covers the amount of leftover drinks. Pam had more soda left over than apple juice. Soda is 1/2 and apple juice is more than a half. No, it's correct. Pam had left soda left over than water. No, Pam had less water left over. Yeah. Joe made a table to show the time it took him to walk to school on different days of the week. Which days did Joe walk to school in less than half an hour? Okay, so Monday it's less than half. And 1/3 Thursday. You got it. Okay. Cool. Let's start the quiz. Plot 3/4. Plot 2/4. So clearly 3/4 is greater than 2/4. Oh shit, 9 problems. Which picture has an area equivalent to 4/8 shaded? No, that's 6. Oh, there we go. Choose one answer right there. Wait, this is 3/4. This one is equivalent. 1/6 shit. Half. Irma compared 4/6 and 2/5 by comparing each fraction to 1/2. 4/6 is greater than 1/2. That's true. It's less than 1/2. That's true as well. So 4/5 is greater than. Yeah, Emma is pretty clever. She did not make a mistake. She's clever. What fraction is equivalent to point A? It's a half. 4/8. Choose one answer. Yeah, 4/8. Compare using lesser. Okay. So okay, 2, 5, and 3. So we have 30 common denominator. See, 9. This one's 30 and 5. So yeah, this one's greater. Which of the fraction are equivalent to 2/4, 1/2, 4/8? Put down. Oh shit. Okay. That's gonna be 4/8. And okay. I don't actually do this. This actually should be like that. No. 1/2, 7/8, and 5/4. Right? Oh shit. Simplest form. Okay. So this is the both are divisible by 6. We have a 6/8 and 3/4. Roger has 3 pieces of yarn described below. A red piece of yarn that is 3/4 meter long A yellow piece of yarn that is 6 meters long. A blue yarn piece, or blue piece of yarn that is 1/4 meter long. Which same great compares to the length? Okay. The red yarn is longer than the yellow yarn. Red, yellow. Red is longer. 3/5 and 6/10. The red is definitely longer. Yeah, man. Wow. Wow, what the heck? This is insane. Oh shit, I didn't. Fuck the last question, I hate it. Okay, the blue yarn is longer than. No, the blue yarn is shorter than the. Oh my god. Kidding me? Come on. And now I downgraded one of my. This is. Okay. You made it able to show the length of his walking sticks. Which walking sticks measured less than 3? Oh shit, this is hard. Less. So 3/5 is the same as 6/10. Less than. So 1/2 is less. And 4. Okay, stick 2 and 3. A red ribbon that's. John has 3 color ribbons. Okay. The yellow ribbon is longer than the blue ribbon. Yellow ribbon 1/10. And the blue ribbon is longer. Oh shit, it's right or wrong. It's wrong. It's wrong. The red ribbon is shorter than the blue. Red is shorter than the blue. Oh yeah, yeah, it's shorter. So. Katie made it able to show how much time she spent on last week. On which activity did Katie spend more than 2.5 hours? Katie spent more than 2.5 hours. Same as 4/6. So it's more than half. More. So no. 2 answers right. This one's definitely. Not sure about 3/4. But I'm pretty sure it's math and reading. Adam, Kim, and Harry ate pizza for dinner. The amount they ate is listed below. Harry! Harry ate less pizza than Kit. Oh shit, it's gonna one cholo pizza. Kim ate 1/4. Okay, let's do the quiz again. Okay. D is 2. Okay, so oh shit. 2, 4, 6 votes. But I know this is 6, but let's check in terms of the number line. 1, 4, 4, 6. Ah, yeah. Compare. This is half. This is both half. They're equal, man. But 4, 6. 4, 6 and 4, 4. Okay, so 4, 4 separately. Oh man, this is hard. Okay. It's gonna be 25. Let me see. 100 and then 25. And this one's. Oh shit. Okay. Holy shit, this is hard. What value of C makes the equation true? Shit, is this supposed to be 10? Let's see. 6 and 10. 6 10 30. For that 30, we can 5, 15. And for 10 to the 30, and 3. It's gonna be 12. Holy shit, it's not. Wow, this is pretty hard. Okay. So this is 10, 30. To get, it's gonna be 5, 15. But the distance that country only is gonna be, no, it's not 10. It's supposed to be 8. This is 8, right? Oh yeah, I mean this 3 6 is equals to 1 1/3, right? No, no, what do you mean 1/3? Oh shit, this is just 1/2. Oh my god, what am I thinking? Oh shit, 3 6. They're both a half. Ah, crap. It's just a half. Oh my gosh. Charlie made it able to show how much time he spent on activities last week. More than half. Okay, swimming is definitely more than half. No, yeah, and cooking. Right? Simplest form, let's see. Okay, it seems that uh, this is divisible by 7. So we have 4 and 9, right? Because that time 7, we had 28 and 63. So 4 and 9 seems in simplest form. Yeah. Graph 3, 12, and 7 plots on the number to show how each fraction relates to 1. Alright, so this definitely great verbs, and this one's greater than. So. Cool, okay, cool. Nice. Okay, I've been recording for 2 hours and my 28% mastered and only 2 hours in. Oh. Okay, let's go 2 hours in, 28% mastered only. Let's go for more. Let's push more. Let's do 1 hour more.
We're asked to rewrite the following two fractions as fractions with a least common denominator. We're asked to rewrite the following two fractions as fractions with a least common denominator. Least common denominator. So a least common denominator for two fractions is really just going to be the least common multiple of both of these denominators over here.
Yeah.
And the value of doing that is then if you can make these a common denominator, then you can add the two fractions, and we'll see that in other videos. But first of all, let's just find the least common multiple. So the least common, let me write it out because sometimes LCD could mean other things. So least common denominator of these two things is going to be the same thing as the least common multiple of the two denominators over here. The least common multiple of 8 and 6. And a couple of ways to think about least common multiple. You literally could just take the multiples of 8 and 6 and see what their smallest common multiple is. So let's do it that way first. So multiples of 6 are 6, 12, 18, 24, 30, and I could keep going if we don't find any common multiples in this out of this group here with 24. Any of the multiples in 8. And the multiples of 8 are 8, 16, 24, It looks like we're done, and we could keep going, obviously. 32, so on and so forth. But I found a common multiple, and this is their smallest common multiple. They have other common multiples, 48 and 72, and we can keep adding more and more multiples, but this is their smallest common multiple, their least common multiple. So it is 24. Another way that you could have found that least common multiple is you could have taken the prime factorization of 6. You say, hey, that's 2 and 3. So anything that is the least common multiple has to have at least 1, 2, and 1, 3 in its prime factorization in order for it to be divisible by 6. And you could have said, what's the prime factorization of 8? It is 2 times 4, and 4 is 2 times 2. So in order to be divisible by 8, you have to have at least 3 2's in the prime factorization.
1 3.
So to be divisible by 6,
So 2 times 2
you
times
have
2
to have a
times
2
3.
times a 3. And then to be divisible by 8, you have to have at least 3 2's. We only have, or you have to have 2 times itself 3 times, I should say. Well, we have 1 2. Now let's throw in a couple more. So then you'll have another 2, and then another 2. So this part right over here makes it divisible by 8. And this part right over here makes it divisible by 6. If I take 2 times 2 times 2 times 3, that does give me 24. That gives me 24. So our least common multiple of 8 and 6, which is also the least common denominator of these two fractions, is going to be 24. So what we want to do is rewrite each of these fractions with 24 as the denominator. So I'll start with 2 over 8. And I want to write that as something over 24. I want to write that as something over 24. Well, to get the denominator to be 24, we have to multiply it by 3. 8 times 3 is 24. And so if we don't want to change the value of the fraction, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator by 3 as well. 2 times 3 is 6. So 2 eighths is the exact same thing as 6 24ths. To see that a little bit clearer, you say, look, if I have 2 eighths, and if I multiply this times 3 over 3, that gives me 6 over 24. And this are the same fraction because 3 over 3 is really just 1. It's 1 whole. So 2 eighths is 6 24ths.
Amazing.
And let's do the same thing with 5 6. 5 6. So 5 over 6 is equal to something over 24. Let me do that in a different color. I'll do it in blue. Something over 24. To get the denominator from 6 to 24, we have to multiply it by 4. So if we don't want to change the value of 5 6, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator times 4. 5 times 4 is 20. 5 6 is the same thing as 20 24ths. So we're done. We've written 2 eighths as 6 24ths, and we've written 5 6 as 20 24ths. If we wanted to add them now, we could literally just add 6 24ths to 20 24ths. And I'll leave you there because they didn't ask us to actually do that.
Over 24.
You have two fractions, 1/4 and 5 6, and you want to rewrite them so they have the same denominator and have whole number numerators. What numbers could you use for the denominator? So here's our fractions, 1/4 and 5 6, and we want to rewrite these fractions to have new denominators. So we currently have a 4 and a 6 as our denominator. And can we just pick any new thing, like maybe 5? Could we say, let's change them both to have 5 as the denominator? The answer is no. We have to pick a multiple of 4 and 6. A multiple, some number that we can multiply 4 and get this number as an answer. So for example, for 4, some multiples of 4 would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. Those are multiples of 4. And let's just pause here and look at why we have to pick a multiple of 4 and 6. Why we can't just pick any number, but we have to pick a multiple of our denominators. So the fraction we were just talking about was 1/4. We could look at either one, but let's look at 1/4. Here we have a picture showing fourths. And to show 1/4, we shade one of these 4 equal size pieces. Well, maybe I want to change this and I want to say I want 2. I want 2 as my numerator. So to have a numerator of 2, I'm going to need to split this fourth up here into 2 pieces. Now I have 2 shaded pieces. So can I say this is 2, 1, 2 out of 1, 2, 3, 4, 5 pieces? It's not 2/5 because these are not equal size pieces. So if I split this fourth right here in half, I need to split all of them in half. And what I'm doing is doubling the amount of pieces. So now this is 2 pieces, this is 2, and this is 2 because we need equal size pieces. So now this is 1, 2 pieces out of 1, 2, 3, 4, 5, 6, 7, 8 equal size pieces. So 2/8. And you can see 8 is a multiple of 4 because we multiplied by 2. And that's what we did. We multiplied each of our pieces by 2. We also multiplied our numerator by 2 because that was also doubled. The amount of shaded pieces doubled when the entire amount of pieces doubled. And we don't have to do this just with 2. We could do any multiple of 4. For example, we can do one more here. If we, again, let's shade 1/4. One of the 4 pieces. And maybe this time we want to split it into 3 equal size pieces. So to have a new numerator of 3, and these should be equal sized. Here's a numerator of 3. But we can numerator of 3, and if we, again, let's shade 1/4. One of the 4 pieces. And maybe this time we want to split it into 3 equal size pieces. So to have a new numerator of 3, and these should be equal sized. Here's a numerator of 3. But we can't do our denominator yet because we don't have equal size pieces. So to get equal size pieces, we'll need to split each of these fourths into 3. So we are tripling the amount of pieces. So now we have 3 shaded pieces out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12. And I could have figured that out without even counting because I knew that we tripled. This time we multiplied
by 3.
Our original denominator times 3. We tripled. And we also multiplied our numerator times 3.
Times 3. Numerator.
So these are the multiples, 8, 12, and so on. And so those are the denominators we can pick. Something that we can multiply our denominator by. So we can multiply the entire amount of... So these are the multiples, 8, 12, and so on. And so those are the denominators we can pick. Something that we can multiply our denominator by, so we can multiply the entire amount of pieces.
So we can
multiply the entire amount of pieces. And again, so this is super clear, 1/4 and 2/8 and 3/12, they all represent the same amount. Whether we had 1/4 the original, here's 2/8, 3/12, they're all equivalent. They all represent the same amount. They're just different ways of writing the same number. Back to our original question, what denominators can we use for fourths and for sixths? Well, we know we need to use multiples, so let's look at the multiples. For 4, we've already gone through some of these. The first multiple of 4 is 4 times 1, which is 4. Second multiple of 4 is 8. 4 times 2 is 8, so we could split our fourths in half and get eighths. Or we could say 4 times 3 is 12, which we showed again, where we split our fourths, each fourth into 3 equal pieces. Or we could do 4 times 4, which is 16. 4 times 5 is 20.
Come on, girl.
4 times 6 is 24, and so on. The reason I'm stopping at 24 is I've looked at my answer choices, and I can see the largest possible answer is 24, so I don't need to write any larger multiples. There are many, many, many more multiples of 4, but we don't need to list them all because the largest number we're going to have to consider is 24. Let's do the same for 6. we could leave our sixths alone, 6 times 1, and keep 6 pieces. Or we could double our 6. 6 times 2 would be 12. If we doubled the pieces, we would have 12 pieces. We could say 6 times 3, which is 18. Or 6 times 4, we could divide each of our sixths into 4 pieces. And we'd have 6 times 4, which is 24, or 24.
12, 18, 24, wow.
And so on. Again,
No,
I'll
12 and
stop at
24
24 since it's the largest number we need to
Can use
consider.
B and D.
So down to our answer choices. What numbers could we use for the denominator? Could we use 8?
No.
Let's look at these lists. 8 is a multiple of 4, so we could definitely split fourths into 8s. But 8 is not a multiple of 6, so we cannot split sixths into 8s. So 8 will not work as a denominator for both fractions. How about 12?
Why do you think so
12
slow?
we can see is a multiple of 4, and we showed that. We drew that already. And 12 is a multiple of 6. We could split our sixths into 2 equal pieces each, and we would have twelfths. So 12 does work. 12 is a denominator, a common denominator for fourths and sixths. 18 is here on the sixths. We could split sixths into 18 because 18 is a multiple of 6, but it is not a multiple of 4. So we can rule out 18. 18 is not a common denominator. And 24, you may remember, was the last number we wrote on both of them. So yes, 24 could be a denominator for fourths and sixths. So we could use either 12 or 24. And there's a lot more numbers we could use too as common denominators, but from these choices, we could use 12 or 24 as a common denominator for fourths and sixths. And just a note, lots of times people like to use the smallest one, the least common denominator, which in this case is 12. And it makes a lot of sense because it's easier to do computation with smaller numbers, but you don't absolutely have to use the smallest one. You could use 12ths or 24ths or lots of other options. But again, 12ths is probably the simplest one to work with just because generally it's easier to work with smaller numbers. But for this question, the common denominators we can use from these choices for fourths and sixths are 12 and 24.
Cool.
Rewrite each fraction with a denominator of 10. So we have two fractions, 3/5 and 7/2, and we want to take their denominators of 5 and 2 and change them to be a common denominator of 10. So let's start with 3/5,
6, 10,
and we can look at this visually.
Holy shit, and
Here we
35,
can use
10.
this rectangle to represent a whole, one whole. And to show 3/5 of that whole, we're going to need to divide it into fifths, or 5 equal pieces. So let's do that. We'll try to make these as equal as possible. And so we have 3 pieces, and then finally, there we go. So these should represent 5 equal pieces, or fifths. And to show 3/5, we need to shade 3 of those 5 pieces. So 1, 2, 3 of those 5 pieces should be shaded in to show 3/5. But we've decided we don't want fifths anymore. Now we want tenths. We want a new denominator of 10. So to change this fraction over here, to change this to be tenths, we need to split each of these fifths in half. We need to double the amount of pieces. So we can do that here. And now, instead of fifths, or 5 equal-sized pieces, we have tenths. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we found a way to have tenths without changing the amount that's represented. The same amount is still shaded, but now we have tenths. So our denominator doubled. We multiplied it by 2. We have twice as many pieces. But look at what happened to our numerator. Instead of 3 pieces, now we have 1, 2, 3, 4, 5, 6 pieces. It also doubled. It also was multiplied by 2. Because if we double all of the pieces, Well, then the shaded ones will also double. Each of those pieces also split in two, so now there's twice as many shaded pieces. So 3/5 can be rewritten as 6/10. 3/5 is equal to 6/10. And again, we didn't change the fraction. We didn't change how much was shaded. 3/5 and 6/10 represented the same amount. We just changed the denominator and wrote it a different way. So 3/5 can be rewritten in tenths as 6/10. And now for 7/2, we want a denominator of 10. So we could draw it out, or we could try to use this pattern we just noticed up here to figure out how to make halves turn into tenths. To get from fifths to tenths, we had to double or multiply by 2. To get from halves to tenths, we'd have to multiply each of our pieces times 5. Times 5. Each of our halves would be split into 5 pieces. So we'd multiply 2 times 5 to get tenths. And, like the pattern showed us up here, if the denominator is multiplied by a number, we multiply the numerator by the same number, because those shaded pieces would also be split 5 times.
I'm
So
kind
we
of waiting for
multiply
it
our
to draw.
7 times
draw
5
that.
also. These should
How would
match.
that be
The numerator
visualized?
and denominator are multiplied by the same number, and 7 times 5 is 35. So 35 tenths
35.
is equal to 7/2.
35.
So to change these two fractions to have a common denominator of 10, 3/5 will become 6/10, and 7/2 will become 35/10.
tenths. Yeah. Okay, that's cool. Common denominators review. When fractions have the same denominator, we say they have the common denominators. Having common makes things in comparing, adding, subtracting fractions easier. Finding common denominator. Finding common are for 2 or more fractions to list the multiples of each until we find the smallest they have in common. Find a common denominator for 7/8 and 3/10. The number is 8 and 10. Let's list multiples of each. Multiples of 8, 16, 24, 32, 44, 8, 6, 6, 4, 7, 3. 18, 20, 30, 40, 68. 40 and 8 are common multiples of 8 and 10, so we can use either of these as a common denominator. Most often we will use smallest common denominator with small numbers. Let's use 40 for our common denominator. Writing fraction with a common denominator. Now, we need to write 7/8 and 3/10 with a denominator of 40. We need to figure out what to multiply each denominator by to get 40. So, 8 times 5 is 40, and 10 times 4 is 40. Now we multiply the denominators with same numbers as their denominator. Okay, so it's going to be 35, it's 12. Now we write 7, 8, and 3/10 with a common denominator. 35, 40, and 12, 40. Note, the new fractions are equal to their original form. However, they're easier to work with in numbers the same. Yeah, true. You have two fractions, 2/5 and 3/10. You want to write them so that they have the same common denominator and whole numbers and whole number numerators. What number could you use for the denominator? Let's get that. Please choose the correct number of answers. Wow, this is graded? Okay. Oh yeah. Do 5 and 10. Grace has won trophies in several sports. She won 1/3 of her trophies for soccer and 1/2 of her trophies for basketball. How many trophies could Grace have? What? What the heck? What the hell is this? Grace has won trophies in several sports. She won 1/3 of her trophies for soccer and 1/2 of her trophies for basketball. How many trophies could Grace have? What the heck? Yo, what the heck? This is insane. Am I looking for the common denominator? Oh, okay. There's one. Okay, let's just go for the common denominator. So use 6, 18. Oh no, not 9, 14. No, that's insane. What the hell? 16 or 18. It's okay. Which that's pretty weird. I mean, which Grace could have 6 or 18 trophies. I mean, that's they're just the common denominators. But for all the trophies, it's just 1/3 and 1/2. So it's not everything. So I mean, if I add like 6/10, okay, 6. This would 3. Uh, to make this, okay, 3 6 and 2 6. If I add 2 6 and 3 6, it'll be 5 6. You can't say it's 6 or 18 because you have a 1/6 left that wasn't added in this. They're just common denominator for the 1/3 of the soccers and 1/2 of the basketball. But all in all, there's still not enough. You have 1/6 left of trophy. It could be in other sport, like chess. Okay. List the 5 first multiple terms of each fraction in order. 4, 12, 10. What's the least common denominator? 12. Rewrite each fraction in denominator 18. Okay, it's gonna be 3 and 18. Yeah. The 4, 18. Check. List the first 5 multiples of the denominator in each fraction in order to least to greatest. Wait, what am I supposed to do here? What is the least common denominator of the two guys? Write each fraction with a denominator of 24. Alright, okay. So for this to go to 24, you have to multiply it by 8. So we have 16, 24, and this one by 24 multiplied by 3 of 15. 16, 24. Oh shit. And 15, 24. Right? By 8, yeah, man. We have two fractions, 5/8 and 5/4. We write them so that they have a common denominator and whole number numerators. What number could be used for the denominator? Could use 8 and 16, man. List the first 5 multiples of the denominator in each fraction, order of least to greatest. Okay, 6, 12, 15, and we have 5, 10, 15, 20. That's the least common denominator. And 15 for this common denominator. Okay, I'm 30%. I want to go like half. So I'm gonna continue the last half. Oh shit, that's a lot. Waste 9? Holy crap, that's insane. And I just finished quiz 2. Holy shit. Alright.
So let's think about all of the different ways that we can represent.
How long am I recording? Okay, our start 8 seconds.
7 ninths. 7 ninths. So let's just visualize 7 ninths. So here I have 9 equal sections, and 7 ninths you could represent as 7 of those equal sections. So let me get myself a bigger thing to draw with so that I can fill this in fast. I don't like how that looks. I'm going to use the paintbrush. So here we go. So that's 1, 2.
What was the difference?
So I don't like how that's 1, 2, 3, 4. You know where this is going. 5, 6, and 7. So that's one way of representing 7/9. We already know that. That's not too interesting. But let's see if we can represent 7/9 as a sum of other fractions. So let's imagine maybe we can represent it as, let's do it as 2/9. Use a different brush here. So let's represent it as 2/9. 2/9 plus, I don't know, let's see, maybe 3/9, but that doesn't quite get us to 7/9 yet. 2/9 plus 3/9 is going to get us to 5/9. So we're going to need 2 more. So it's going to be plus another 2/9.
Holy shit, 2 more.
Plus another 2/9.
We're going to need 2 more.
Plus another 2/9. So what would this look like? So let's just draw another grid here. So this is going to look like, I'll try to do it right below it so that we can see how they match up. So we have 2/9. We have 2/9. This 2/9 right over here. Well, we have each of these is a 9th. We have 9 equal sections. So 2/9 is going to be, so we're going to get 1 and 2. And then we're going to add 3 more 9ths. So 1, 2, 3. So we add 3 9ths right over there, and then 2 more 9ths, and then 2 more 9ths. 1, and 2. So notice when I added 2 9ths to 3 9ths to 2 9ths, this equals 7/9. And we know that when we add a bunch of fractions like this that have the same denominator, we can just add the numerator. And this is why. This is 2 9ths plus 3 9ths times 2 9ths is going to give me 7/9. Let's do this one more time. This is actually a lot of fun. So let me draw my grid again.
This is pain and torture.
Let's see what we can do.
No, I'm just kidding.
So
It's a lot of fun.
Pen tool out. And make sure my ink isn't too thick. Well, this is fine. And let's add a couple of 9ths here. So let's add first 1/9, and I'm going to write all the 9s in blue. And let's add 2 9ths, and then we could add, I don't know, maybe we could add, let me give some space here so we can add more. And maybe we could add 3 9ths, and then we could add, let's see, that won't get us, you see, 1/9. Actually, let me just write this down. I'm going to try to add 4 fractions here. So let's add first 1/9, see where that gets us. So 1/9 is going to get us right over here. So that's 1/9. So let's say we add 2 9ths to that. So 2 9ths. Get my little paintbrush going on. So that's 1 and 2 more. 2 9ths. So that still doesn't get us there. This gives us a total of 3 9ths. 1 plus 2 is 3. 3 9ths. So let's add 4 9ths. 4 9ths, and I'll do that in this blue color. So 4 9ths. That's different enough. 4 9ths. So let's see where this gets us. Actually, well, why not? So 4 9ths. And so that's going to get us 1, 2, 3.
Are we going to add 0 9ths?
4. So that looks like it got us all the
overflow.
way. Because 1 plus 2 plus 4 is going to give us 7 9ths. So what can we put here? Well, we could say 0 9ths. Why not? So we could call this one right over here 0 9ths. And how would we visualize that? Well, we're saying none of these. No 9ths right over here. So this is 1 9th plus 2 9ths plus 4 9ths is equal to 7 9ths. So these are all different ways to decompose the exact same fraction.
Decomposing a mixed number.
Let's now think about different ways to represent a mixed number. And let's say that our mixed number is 2 and 1.
Yo, you haven't even introduced me what's a mixed
Actually, let's make it a little bit more interesting. Let's make it 2 and 1/4. 2 and 1
Yo, what is
fourth.
this?
So let's first think about the whole number part. The 2.
This is a scam.
Well, the 2 is going to be...
Why are you doing?
The 2 is literally 2
numbers?
holes. You could literally view that if you want. Right here, we've drawn each hole. We've cut it up into sections of 8. So it literally is 8 eighths. So let me just do it like this. So the 2 is this whole region right over here. That's 1. So this right over here is 1. And then this right over here is 2. 2 holes. So let me paint that in. So that is 2 holes. And then I have 1/4. So this last piece, this last hole is divided into 8 sections. So let me divide it into fourths first. So that's 1/4, 2/4, and 3/4. So we want one of those 4 to be filled in. One of those 4 in orange. So one of those 4 to be filled in. So just like that. You might notice that I filled in 2 of the 8s, and that's because 1/4 and 2 eighths is the same thing. So there I've represented this mixed number, 2 and 1/4. Let's see how we can decompose this. So let's get our grids back. So how else could we do it? And I'm just going to throw a bunch of fractions up there and see what I get. See what I get. So the first thing I'm going to throw out is 1/2. So let's say that I want to throw out 1/2. So how would I represent 1/2 here? Well, if I take one of these holes and I put it into 2 sections right over here, a half would be this section right over there. So let me color that in. So we have a half. So I'm first going to add a half, which is the same thing as 4 eighths. And you see that I just filled in 4 out of the 8 sections, which is exactly half of this first hole. So we're making some progress. Now let's throw in, I don't know, let's throw in 3 eighths. So what would 3 eighths look like? Well, 3 eighths, that's going to be, these are literally, each of these boxes are literally an eighth. And I could fill it in however I want, but let me just put, this is 1, 2, and 3. And then let's fill in plus, I don't know, plus another 8 eighths. 8 eighths. Now what's 8 eighths? Well, 8 eighths is a whole. And I'll do that over here. I still haven't filled this one in yet, but I'll fill in this one right over here.
You should fill it
So
box
let's
by
do
box,
that.
okay?
So 8 eighths. So that's 1/8, 2 eighths,
Nice.
3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, and 8 eighths. And it's a whole. So I have a whole hole here. So that's 8 eighths. I want to make this one a whole because I want to get to 2. So let me put in a 1/8 there. So plus 1/8. So plus 1/8. Well, that's going to be this one right over here. So that's my 1/8. And then let's add another, I don't know, let's add another 2 eighths. Plus another 2 eighths. Plus 2 eighths. Well, this is an eighths right over here, so 2 eighths is going to be 2 of these. And notice, you see that the 2 eighths is the same thing as 1/4. If you took each of these, if you took this 1/4 and split it into 2, so you have two times as many pieces, it becomes 2 eighths. And you see that if 1 times 2 is 2, 4 times 2 is 8. So that 1/4 is the same thing as 2 eighths. You see the 8 eighths is the same thing as a whole. And you see you can make another whole out of 1/2 plus 3 eighths
And
plus
1/8.
And they add up to a whole. And just to make sense of why that worked, this is 1/2 could be written. 1/2 is the same thing as 4 eighths, because you see that we filled in the 4 eighths. Then you have 3 eighths, and then you have 1/8. 1/8. And if you add all of these together, 4 eighths plus 3 eighths plus 1/8, you are going to get, in terms of eighths, 4 eighths plus 3 eighths plus 1/8 is going to be 8 eighths. 4 plus 3 plus 1 is 8. So you get 8 eighths, which is this entire whole. So hopefully that helps give you a visual understanding of what we're doing when we're adding and decomposing these fractions a little bit more.
Oh, that was it? Okay. Okay, so decomposing fractions. The decompose of a number. We break it into smaller parts. Cool. You can decompose. Fractions, like all numbers, can be decomposed in many ways. Decompose. It's a pretty cool word. In our previous lessons, we say break up the numbers. I think decompose is pretty rad. Tape diagram. Let's decompose 5 nines. One way we can decompose 5 nines. 2 nines plus 3 nines. 2 nines plus 3 nines equals 2 plus 3 nines. This is 5. Another way we can decompose it. 1 nines, 2 nines, and 2 nines. Yep. Examples number line. How can we decompose 6 fourths? When we get decompose in 1/4, oh shit, there's a lot of 1/4. Yeah. Another way we can decompose is 6 fourths. Is 3 fourths plus 3 fourths. Yeah. Do you want to check out this video? Pretty sure watch the video. It's this video. Let's see. If we haven't watched this video, I think we can. Oh yeah, we've read. It's the last video. Which of these sum equal 14, 10? No, it's not 14, 10. 14, 10. No, it's not. Which fractions add together to make 3 sevens? Oh wow, this is cool. Okay. Gonna make 7? Let's make 7. Completes 5, 6, 3/5. Determine whether each expression is less than, equal to, or greater than 5/8. Okay. What is this? So this is equal to 5/8. This is greater than 5/8, and this is less than 5/8. Okay, we're gonna first take the practice and then the quiz. Okay. Now let's practice. Let's go. Which fractions add together to make 5/8? This one will make 5/8. Is each expression less than or equal to 6 fourths? Oh shit, this one's greater than 6 fourths. This was equal to 6 fourths. This is also equal to 6 fourths, yeah? Which of these sums equal 5, 6? It is 5, 6. This is also 5, 6. This is 6, 6. We haven't done subtracting fractions, but okay. Complete this equation. Wait, what? So 4, 5, that's 9, 8, right? Okay. Let's not make a mistake. This is 4. Oh shit, we're gonna make a mistake. 4 plus 9 is 13. It's gonna be 10. Yo, yeah, 10. Wait, what? Oh shit, I'm turning an idiot. This is 4, 7, 8. And then 8. And 6, 10. Okay. Which fractions add together to make 11? Okay. This is 6. Okay. Okay. This is 5, 6 greater than, is equal, and this is greater than as well. Oh no, this is less than, this is 4. Which of these sums equals 16, 8? Alright, this is 16, 8. 10. This is, no, this is, oh, there we go, this is 16, 8. Alright, cool. Next. Each tape diagram represents one whole. Choose a tape that represents the equation 1, 8, 2, 8, 2, 8, 5, 8. 1, 8, 2, 8, 2, 8. It's gonna be 5 8s, right? This is 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh god. 1. Oh, okay, this is 8s. This is 4. Sorry, okay. Choose the equation representing tape diagram. Okay. They say total 1, 2, 7, 8, 9, 10, 11, 12. Okay, this is 12. So one of these. Definitely this one. So 4 plus 1. It's been 9. Wait, what? This doesn't even add up. Oh, this adds 5. Yeah. Choose the equation represented by the following number line. Okay, that's 1/3 plus 3/3 plus 1/3. Yeah, 5/3. Want to know? Choose a number line that represents the equation 2/6 plus 3/6 plus 2/6 plus 7/6. Okay, this is. Oh shit. This is not. It's this one. Let's move to the quiz. Write each fraction with a denominator of 24. So this is going to be multiplied by 3. So 9/24. And then for the bottom one, we multiplied by 4. We get 28 over 24. Right? Yeah. Complete this equation. 5, 6, 9/5. Each tape diagram represents one whole. Just diagram. Okay. 4/3 is gonna be it. Which fraction add together to make 13 halves? Okay, we have 8 plus 10, and then this guy is gonna make 13 halves. Oh, fuck. What? 8, 9, 10, 11. Oh shit, 13, not 11. Oh crap, I made a mistake. Okay. Should be 8. Crap, it's this one. Because 4, 12, and 1. God damn it. No, I will have 10 more questions. Just because I made a mistake. We have 10 fractions, so we want to run so that they have common denominators and whole numbers. Which numbers can we use down? Here it's just 10, 20. Yo, no change. Okay, cool. Didn't level down. It's nice. Which means I could just take the quiz again. Okay, cool. This is the first 12, 18, 24, 30. What's this? 10, 30, 34. What is this common denominator for the two fractions? 30. Is this okay. 6, 12, 14, it's greater than. 5, 9, it's less than. 3, 6, 7, 12. Choose the equation represented found in the tape diagram. Okay, so this is by 6. Okay. Which of these sums equal 20? Yeah, my face is so shite. Okay, 8. Which of these sums equal 20? Okay, let's make. Holy shit. Oh, this is 15 and then 5. Okay. Choose the equation represented by the following number line. Okay, we're moving 1, 2, 3, 4. So fourths, right? Yeah. Then 3/4 and then plus 2. Okay. Okay, cool. Then we're gonna go to the third.
So we're asked to add 3/15 plus 7/15 and then simplify the answer. So just the process when you add fractions is if they already, well, first of all, if they're not mixed numbers, and neither of these are, and if they have the same denominator, in this example, the denominators are already the same. The denominator is 15. So if you add these two fractions, your sum is going to have the same denominator, 15, and your numerator is just going to be the sum of the numerator. So it's going to be 3 plus 7, or it's going to be equal to 10 over 15.
Wow, 2/3.
Now, if we wanted to simplify this, we look for the greatest common factor in both the 10 and the 15. And as far as I can tell, 5 is the largest number that goes into both of them. So divide the 10 by 5.
What
So
did
divide
they
the
call
10
it?
by 5 that goes into both the 10 and
Greatest
over
common
15.
denominator.
Now, if we wanted to simplify this, we look for the greatest common factor in both the 10 and the 15. And as far as I can tell, 5 is the largest number that goes into both of them. So divide the 10 by 5. So you divide the 10 by 5, and you divide the 15 by 5. And you get 10 divided by 5 is 2, and 15 divided by 5 is 3. You get 2/3. Now, to understand why this works, let's draw it out. Let's split something up into 15 sections. So let me split it up into 15 sections. Let me see how well I can do this. Or actually, even a better way, an easier way might be to draw circles. So, well, let me do the 15 sections. So let me draw. So that is one section right over there. That is one section, and then if I copy and paste it, so let me copy and then let me paste it. That is a second section, and then third section, fourth section,
Oh shit, you're
and
gonna do
then
this
we have
15
a
times?
fifth section. Let me copy and paste this whole thing. So that's 5 sections right there. So let me copy and then paste that. So that is 10 sections. And then let me do it one more time. So that is 15 sections. So you can imagine this whole thing is like a candy bar or something. And we have now split it up into 15 sections. Now, what is 3/15? Well, it's going to be 3 of the 15 sections. So 3/15 is going to be 1, 2, 3. 3/15. Now to that, we're adding 7 of the 1/15 sections, or 7 of the sections. So we're adding 7 of those to it. So that's 1, 2, 3, 4, 5, 6, 7. And you see now, if you take the orange and the blue, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the sections, or 10 of the 15 sections. And then to see why this is the same thing as 2/3, you can just split this candy bar into thirds. So each third would have 5 sections in it. So let's do that. 1, 2, 3, 4, 5. So that is 1/3 right there. 1, 2, 3, 4, 5. That is another third right there. And notice, when you do it like this, we have filled out exactly 2 of the thirds. This is the third third, but that's not filled in. So 10/15 is the same thing as 2/3. We're asked to subtract and simplify the answer. And we have 8/18 minus 5/18. So subtracting fractions
Nice
is
subtraction.
very similar to adding fractions. If we have the same denominator, the denominator in the difference is going to be the same as the denominators in the two numbers that we're subtracting. So it's going to be 18. And our numerator is going to be the difference between the numerators. So in this case, it is 8 minus 5. And this will be equal to 3 over 18. Which is the answer, but it's not completely simplified because
No,
both
1/6.
3 and 18 are divisible by 3. So let's divide them both by 3. So you divide 3 by 3, you divide 18 by 3, and you get 3 divided by 3 is 1. 18 divided by 3 is 6. So you get 1/6. And just to see this visually, let me draw 18 parts. So let me draw 18 parts here. So might be a little bit of a messy drawing. Try the best I can. So let me draw 6 in this direction. So that is 3 right there. And we have another 3. So that's 6 parts. We split this into 3 columns. So there we go. We have 18 parts. Now 8 over 18. 8 over 18 is equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 over 18. And now we want to subtract 5 of the 18ths. So we subtract 1, 2, 3, 4, 5. Now what do we have left over? Well, we have 3 of the 18ths left over. So you have that right there. You have 3 of the 18ths left over. Now, if you turn 3 of the 18ths into one piece, how many of those bigger pieces do you have? This is one of those big pieces. And where are the other ones? Well, this is another big piece right here. This is another big piece right here. Another one, and another one. If you had 18 pieces and you merge 3 of the pieces into one, then you actually end up with only 6 pieces. You end up with 6 pieces. Hopefully you see that each row is one of the pieces now. And the blue is exactly one of the 6. So 3 over 18 is the same as 1 over 6.
Let's add these two mixed numbers, 2 and 5/13 plus 7 and 6/13. And the way I like to think about it in my head, I like to separate out the mixed numbers into the whole number component and the fractional component. So we can rewrite 2 and 5 numbers into the whole number component and the fractional component. So we can rewrite 2 and 5/13 as 2 plus 5 over 13 plus 5 over 13. And then we can write that plus. And then 7 and 6/13 we can rewrite as plus 7 plus 6/13 plus 6/13. 6/13. So all I did is I rewrote this and I essentially expanded out. I broke up the mixed numbers into their whole number parts and their fractional parts. And then what I like to do is I like to add the whole number parts. So this 2 plus this 7. So I'll do that. So I'll do the 2 plus 7 over here. I'll add those up, and to that I will add the fractional parts. So to that I will add the 5/13 to the 6/13 6/13.
It's going to be 9.
So if we add the whole number parts, 2 plus 7 is 9. And the fractional parts, they already have the same denominator in this problem. 5/13 plus 6/13, same denominator. You're going to get 11/13. 11/13. 5 plus 6 is 11. So you get 9 plus 11/13. Well, that's just the same thing as 9 and 11/13. And we are done. Let's figure out what 11 and 12/16 minus 5 and 8/16 is, and then we might have to simplify it down to lowest terms. So the way I like to do these is to kind of separate out the whole number part of the mixed numbers from the fractional part. So I can rewrite this number right over here as 11 plus 12 over 16. And from that, I am going to subtract, and I'll put parentheses here because I'm going to break this part open. I am going to subtract 5 plus 8 over 16. 5 and 8/16, same thing as 5 plus 8/16. But I have to remember, I'm subtracting it. I'm subtracting this whole thing. So I can rewrite it as, I'll rewrite this part, 11 plus 12 over 16. And I'm subtracting 5 plus 8/16, so I can distribute the negative sign. So it's going to be minus 5, negative 1 times 5, and then negative 1 times positive 8/16. So it's going to be minus 8 over 16. Minus 8 over 16. And then I like to do the whole number part separately and then the fractional part separately. So let's do the whole number parts. We have 11 minus 5. I'll write it here. 11 minus 5. We'll do that part. That's the whole number part. And then we have plus 12/16. So we'll do this in pink maybe.
So it's going to be
plus
6
12
and
16ths.
1/4.
12/16 minus 8/16. Minus 8 over 16. And 11 minus 5 is 6. And I have 6 plus. And then our denominators are the same here. So we're going to get something over 16. And 12 minus 8 is 4. So this is the same thing as 6 plus 4 over 16, which is the same thing as writing as a mixed number. 6 and 4/16. 6 and 4/16. And this is the right quantity, but we can simplify it. 4 over 16 can be simplified. Both the numerator and the denominator are divisible by 4. They both have the factor 4. So let's divide both the numerator and the denominator by 4. Divided by 4, divided by 4. Since we're dividing by the same thing, we're not changing its quantity. And so this is equal to, we still have the whole number part, 6, but the fraction part is now 1 over 4. So we get 6 and 1/4.
Oh fuck. Wait, is this row 7? Yeah, right? Wow, why was I confused with this? I mean, 7, 4? Sometimes there's 6, 9, 7. Was I thinking of thirds of 9? It's pretty weird. Why would I think that? It's true. This one's true. Can I just say 1? Man, I want to say 1, but I wanna try 1. Yeah. This is true. This ain't true, man. Adding and subtracting, no regrouping. Okay, cool, no regrouping, thanks. How about the simplification thing? Okay, I guess definitions. 3, 12, 3. Oh shit, how do I do this? Holy fuck, how do I write the number? Oh shit. How do I represent this? Let's say 12 space and then 3 hits. Will this work? Thank you. On 9. Now 1. Oh my god. Sick. Okay, I want to do the quiz 4 and stop.
Write 5 and 1/4 as an improper fraction. And an improper fraction is just a pure fraction where the numerator is greater than the denominator.
Improper.
This right here, it's not a pure fraction. We have a whole number mixed with a fraction, so we call this a mixed number. So let's think about what 5 and 1/4 represents.
What is a pure fraction?
So we call denominator. This right here, it's not a pure fraction. We have a whole number mixed with a fraction, so we call this a mixed number. So let's think about what 5 and 1/4 represents, and let me rewrite it. So if we're talking about 5 and 1/4, 5 and 1/4, and you can literally think of this as 5 and 1/4, or 5 plus 1/4. That's what 5 and 1/4 represents. So let's think about 5. 5 is 5 wholes, or if you're thinking of pi, we could draw literally 5 pies. We could draw 5 pies. And let me just cut up the pies from the get-go into 4 pieces, since we're dealing with fourths. So let me just cut up the pies right over here. So that's 1 pi right over there. Let me copy and paste this. Copy and paste. So I have 2 pies, and then I have 3 pies, and then I have 4 pies, and then I have 5 pies. So this is what the 5 represents. 5 literally represents, so let me circle all of this together. That is the 5 part right there. That is what 5 literally represents. It represents 5 whole pies. 5 whole pies. Now, I have cut up the pies into 4 pieces. So you can imagine each piece represents a fourth. Now, how many pieces do I have in these 5 pies? Well, I have 4 pieces per pie. I have 4 pieces per pie. 4 pieces per pie. 4 pieces. Well, let me just write it here. 4 pieces per pie times 5 pies is equal to 20 pieces. Or another way to think of it, since each piece is a fourth, this is also equal to 20 times 1/4. Or you could just write this as being equal to 20 fourths. So we have 5 whole pies is equal to 20
Holy
fourths.
shit,
We
that's
write it like that.
insane.
20 fourths. Or we could write it as 20 over 4. I've kind of done the same thing twice. So that's what the 5 pies represent. 20 fourths, or 20 pieces, where each piece is 1/4. Now the 1/4 right here represents literally one more fourth of a pie, or one more piece of a pie. So let me draw another pie here. So that is another
Oh
pie.
no, why you didn't
Cut
color
it
the
into
pie
4 pieces.
magenta?
But this 1/4 only represents one of these pieces, right? This is one
Oh, okay.
of the
The one
4
fourth's gonna be
pieces.
the
The 4,
magenta.
the denominator, tells us how many pieces. The 1 tells us how many of those pieces we're dealing with. So it's just this one piece over here. That right there is the 1/4. Now, if we write 5 and 1/4, we just saw that the 5 right here is 20
20 over
fourths. So we
4.
could write this. So we could rewrite this. So let me write it like this. 5 and 1/4. 5 and 1/4 can be rewritten as, this is the
24
same
over
thing as
4.
5 plus 1/4. 5 plus 1/4, which is the same thing as, we just saw that 5 whole pies is the same thing as 20 fourths. 20 fourths. And to see that these are the same thing, you literally just divide 4 into 20. You get 5, and nothing is left over. So 5 is the same thing as 20 fourths. And then this plus 1/4 is the same thing as plus 1/4. So if I have 20 fourths, and I add one more fourth to it, how many fourths do I have?
21
Well,
fourths,
I have
bitch.
21. I
Yeah.
have 21 fourths. Or another way of thinking about it, this 5 is, so this right here
Awesome,
is,
Sal. You're amazing.
that right there is 20 pieces. 20 pieces of pie. And you can even count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But a quicker way is to say, well, we have 5 pies. Each of them have 4 pieces. 5 times 4 is 20. This 1/4 right here represents 1 piece plus 1 piece. So total, we're going to have 21 pieces. So we have 21 pieces where each piece is 1/4. So you could say we have 21 times 1/4, or 21 fourths pieces of pie. However you want to think of it, but we've solved the problem. We're at an improper fraction. We've written 5 and 1/4 as an improper fraction. Now, I've gone through great pains to give you the intuition of what 5 and 1/4 means, but there is a fairly straightforward process for getting straight to
5
the improper
times
fraction.
40 plus
If
1,
you
right?
have, let me color code it. So if you
5
have
times 20 plus 1.
5 and 1 over 5 and 1 over 4, to convert it into an improper fraction, you're going to keep the same denominator. So you're going to have the over 4 there. But your numerator is going to be your your numerator of the fraction part before. So it's going to be 1 plus your whole number times your denominator. So 1 plus, or actually, let me do it the way I tend to think of it. What I do is I take 4 times 5, so let me write that down. 4, and I want to color code it. 4 times 5, 4 times 5, and then to that I add this numerator. So I literally do 4 times 5 plus 1, and which is, so this is equal to 4 times 5 is 20, plus 1 is 21, and then that's over 4. So it's 21 fourths. And although this is kind of a fast way to do it, we're literally doing the exact same thing that we did here in a kind of a slower way. We're saying, okay, 5 wholes is the same thing as 20 fourths. So you take 5, and I figured that out, times 5 times 4. And then I have one more fourth there. So 4 times 5 plus 1 gets 21. Write 7 over 4 as a mixed number. So right now it's an improper fraction. 7 is larger than 4. Let's write it as a mixed number. So first I'm just going to show you a fairly straightforward
1 and
way
3
of doing it, and
fourths,
then we're going
right?
to think about
No?
a little bit about what it actually means. So to figure out what 7 over 4 represents as a mixed number, let me write it in different colors. So this is going to be equal to, the easiest way I do it, you say, well, you take 4, you divide 4 into 7. So you divide 4 into 7. 4 into 7. So 4, if we're dealing with fourths, 4 goes into 7 a total of 1 time. 4 goes into 7 a total of, let me do this
The
in another
remainder is going to
color,
be the numerator.
a
Wow,
total
that's
of
awesome.
1 time. 1 times 4 is 4. And then what is our remainder? 7 minus 4 is 3. So if we wanted to write this in plain, well, let me just do the problem, and then we'll think about what it means in a second. So you see that 4 goes into 7
One
one
time.
time. So you have one whole here. You have one whole. And then how much do you have left over? Well, you have 3 left over. You have 3 left over. And that comes from right over there. That is the remainder when you divide 4 into 7. 3 left over, but it's 3 of your 4, or 3 fourths left over. So that's the way we just converted it from an improper fraction to a mixed number. Now, it might seem a little bit like voodoo what I just did. I divided 4 into 7. It goes 1 time, and then the remainder is 3. So I got 1 and 3 fourths. But why does that make sense? Why does that actually make sense? So let's draw fourths. Let's draw literally 7 fourths. And maybe it'll become clear. So let's do a little square as a fourth. So I'm going to do it, let's say I have a square like
You need
that,
2
and
fourths,
that
right?
is 1/4. Now,
Okay.
let's think about what 7 of those mean. So let me copy and paste that. Copy and then paste it. So here I have 2 1/4s, or you could say I have 2 fourths. Now I have 3 1/4s. Now I have 4 1/4s. Now this is a whole, right? I have 4 1/4s. This is a whole. So let me start on another whole. So now I have 5. Now I have 6 1/4s. And now I have 7 1/4s. Now, what does this look like? So all I did is I rewrote 7 fourths, or 7 1/4s. I just kind of drew it for you. Now, what does this represent? Well, I have 4 fourths here, so this is 4 over 4. This right here is 3 over 4. Notice 7 over 4 is 4 fourths with 3 fourths left over. So let me write it this way. 7 over 4 is 4 fourths with 3 fourths left over. Now, what is 4 fourths? What is 4 fourths? 4 fourths is 1 whole. So you have 1 whole with 3 fourths left over. So you end up with 1 and 3 fourths. So that is the 3 fourths part, and that is your 1 whole. Hopefully that makes sense, and hopefully you understand why it connects. Because you say, well, how many wholes do you have? When you're dividing in the 4 into the 7 and getting the 1, you're essentially saying how many wholes? How many? So the number of holes,
Holes.
or you can imagine the number of whole pies. And then how many pieces do we have left over? Well, we have 3 pieces, and each piece is a fourth. So we have 3/4 left over. So we have 1 whole pie and 3 pieces, which are each a fourth left over.
What is an improper fraction? You must greater than below 6 Okay. This number is a whole number in a proper fraction. Below. What if you have a mixed number was an improper fraction? It's gonna be crazy, but it doesn't make sense. Writing a mixed number is an improper fraction. Write 3 and 4/5 is an improper fraction. 3 4/5. It's 2 4/5. Yep. Alright. Well, let's see it again. As an improper fraction. It's 24. Okay, it's not. It's improper fractions. 18, 23, 6, correct? Oh yeah. It's a mixed number. Okay, let's reverse the shit. 1 and 5/8 is correct. Yeah. Okay, it's gonna be 4 and 4/5, right? It's gonna be 2 and 3. Oh shit, no? Shit, I don't know. Oh yeah. Great.
I've got pairs of mixed numbers and improper fractions, and I want to think about which of the two is larger. So 1 and 7/8, 39 over 10. So you can do this in your head. You could say 10 goes into 39. I'll even write it out. 10 goes into 39 3 times. 3 times 10. You want to find the largest number of times 10 goes into this without going over. So if you,
I guess if your
write
numbers
4 over here, because then that would be 40. That would go over
the normal
39.
number.
3 times 10 is 30. And then you have a remainder of 9.
Great base.
So you could rewrite this expression right over here. Instead of 39 over 10, you could write it as 30 over 10 plus 9 over 10. And 30 over 10 is just 3. So this is equal to 3 and 9/10. And you could do that in your head. You could say 10 goes into 39 3 times, and the remainder is 9. You have your 9/10. And that's essentially just doing this in your head. So now we can compare, and we can literally just look at the whole number parts. This is 1 and something, 1 and 7/8, and we're comparing it to essentially 3 and 9/10. 3 and 9/10 is clearly a larger number. We have a 3 out here instead of a 1. So we will write less than. And the way I always remember it is the opening always faces the larger number, and the opening is large, it faces the larger number, and the point is small, it always points to the smaller number. Now let's do this next one. 4 and 7/8 versus 49 over 9. So let's convert this to a mixed number. 9 goes into 49 5 times, and 5 times 9 is 45. So the remainder is going to be 4. The remainder is 4. So this is 5 and 4/9. Once again, we can literally just look at the whole number parts. 5 is clearly larger than 4. So once again, less than. Point facing the smaller number, opening facing the larger number. Now, 2.5 versus 11/10. 10 goes into 11 only one time, and if you care about the remainder, it's 1. So it's 1 and 1/10, which is clearly smaller than 2 and 1/2. You just look at the whole number of parts. 2 is clearly larger than 1. So we want our opening of our less than or greater than sign to face the larger number. So we would write it like this, and this is greater than. So 2.5 is greater than 11/10. The little point facing the smaller number. 5 and 4/9 versus 47. 47.
Oh shit, this is saying this
7
both
goes
35.
into 40. So let me rewrite this. 7 goes into 40 5 times.
5 times.
And then you're going to have a remainder of 5.
5 over
7 times 5 is 35. You have a remainder of 5 to get to 40.
And now we have different.
So it's 5 and 5/7. And if that looks like I'm doing some type of voodoo, just remember, I'm really just breaking it up. I'm just really saying that 40 over 7 is the same thing as 35 plus 5
9
over 7. The largest multiple of 7
I guess
that is
47
less than
is
this
larger.
number. And this is the same thing as 35 over 7 plus 5/7. And then this 35 over 7 is 5, and 5/7 is just 5/7 there. This one is interesting because we have the same whole number out front on our mixed numbers, 5 versus 5. So now we actually do have to pay attention to the fractional part of our mixed number. We essentially have to compare 4/9 to
Yeah, it's gonna be
5/7. And there's a couple of ways to do
5/7. I
this.
mean,
You
it's
could get
also
them to
greater
have
than
the same
1/2
denominator.
already.
That's probably the easiest way to do it. So you could rewrite, so what's the least
No,
common
the easiest
multiple
way is
of
you
9
could just
and 7?
the 1/2
They share no
thing.
factors, so really the least common multiple is going to
It's
be
nine-
their product.
Yeah.
So if we want to rewrite 4/9, we would write 63 in the denominator. That's 9 times 7. If we multiply the denominator
You could say that
by
4/9
7,
is
we
less
also
than
have to
half,
multiply
and
the
5/10
numerator
is
by
greater than
7.
half, so it's
So
definitely
that will be
5
28.
and 5/7.
Now, 5/7, we're going to make the denominator 63. We're multiplying the denominator times 9. Then we have to multiply the numerator times 9 as well. 5 times 9 is 45. So here it's easy to see. 45 over 63 is clearly larger than 28 over 63.
Yeah.
And so we could write this, and because the whole number parts are the same, and 5/7 is the same thing as 45 63rds, and 4/9 is the same thing as 28 63rds, we can write it that 5 and 4/9 is less than 40 over 7. Another way that you could have thought about 4/9 versus 5/7
halves.
is you could have said, well, how does 4/9 compare to 4/7? We have the same numerator. The denominator here is larger than the denominator here, but when you have a number in the denominator, the larger it is, the smaller the fraction, the smaller the absolute value of the fraction. So this right over here is a smaller quantity than 4/7, and 4/7 is clearly a smaller quantity than 5/7. So 4/9 is clearly smaller than 5/7, so we would have gotten the same result.
Well, wait. It's an insane thing.
We've gotten the same.
Oh, yeah. Right, mixed numbers and improper fractions. Okay. Right, so it's 47 over 10, right? Where's a mixed number? Okay, it's gonna be go 4 times. Oh no, 3 times only. 7, 8. What's this? 24, 27 over 4. It's a mixed number. It's gonna be 4 and 1/3. Right, it's proper shot. It's 47 over 8. It's a mixed number. It's gonna be 4 over 4. The same thing. It's in proper fraction. Okay. 17, 16, 18. Wait, what? There's 16. 23. Yeah, over 8. It's pretty sick. Okay. Compare. Oh shit. Okay. This goes 3 times, so it's definitely bigger. Oh, 5. What are 5? It's insane. I think this is equal, right? I'm pretty sure it's equal. Okay. 2. Well, this one goes. Oh wow, it's amazing. This is bigger, but you know what? I'm gonna write it. Okay. You have 2 over 12. What is this? 24. 6, 7. Versus. I have 7, 2 versus. Holy shit! This is greater. Oh, stop. Okay. So for this to go to 12, we'll go 6, and then it's gonna be multiplied by 6. Wow. Wait, what? No! Multiply by 3 to get 6. So it's gonna be 3. So clearly the left side is larger. Is this correct though? 4, 7, yeah. And then for this to divide by 6. Holy shit. My 6 and... Okay. So clearly the other guy's like. So compare is okay. Holy shit. 2, this one was 3 times high. Pretty cool. Oh, we're done. Okay, next. Oh shit, I'm gonna start the quiz. It's number 4. To subtract. Oh shit, this is hard. Okay, we got 1. And then... oh shit, oh, it's actually easy. 1 and 5 points. Compare the numbers using... this one goes 2 times as well. So, we have 1/3 left. Wait, what? No. 2/3 left. 2/3. Wait, I'm not gonna fuck this up, okay? So 2, 6, 2. And I have 2/3 left for that. And then clearly they are equal, right? Because if you divide this by... oh, no. Divide this by 2, get 2. And then 6, right is mixed number. It is 3, 4, 5. 5, 6. Subtract, we don't want forward. Done. Cool. Okay, that's the quiz. Quiz number 4. How long have I been recording? 50 hours and 35 minutes. Okay, so I mastered 41% only. I'm gonna continue the rest tomorrow. I'm gonna master this part more, this fractions stuff. So yeah, last thing I've done is quiz 4. Yeah, and then we can do like denominator. It's pretty cool. Okay. So how much percent do we have in arithmetic now? From 43, we have 55. Oh, that's pretty sick. It's amazing. It's pretty sick, dude. Okay, 5 and 5. 5 minutes. Okay. Okay. Cool. Let's see from the missions in World of Math. I'm gonna end my video in the end of World of Math screen. Seriously, only gained 1%. Of course. 1%. 3 hours and 30 minutes for 1%. Damn, that's insane. Pretty insane, bro. But yeah. Okay. We're gonna continue tomorrow. So this is I believe this is the 6th session. So yeah. Tomorrow again. Bye.